Question 1 says factorize 2x squared minus 21x plus 45. We have to factorize 2x squared minus 21x plus 45. So we have 2x squared minus 21x plus 45. All right. So to factor any quadratic trinomial, right, we have to write it in such a manner that the product of the terms in the middle, so what will split up 21 in the middle to become, has to be same as the product at the ends, right? So I'll just write, so we need it to be that the sum of the two values is minus 21, right? Because we are using it to replace the minus 21 here, right? But then their product has to be 2 times 45, which is 90, right? So your product has to be 90. So the only two numbers that I can think of would be 15 and 6. So that would be negative 15 and negative 6, right? Because you add them up, you get negative 21, multiply them, you get 90. So this would become 2x squared, and in place of minus 21x, would have minus 15x minus 6x, then plus 45. All right, so now that we've written it such that the product of the values at the end is the same as the product of the values in the middle, okay, we can go on to factor. From the first group here, the first two terms here, I can factor out x, right? And then I would have 2x minus 15. And then from the second group here, I can factor out, that would be negative 3. And I would also have 2x minus 15. All right. So I can factor out 2x minus 15 from both of them. So I would have 2x minus 15. And then from the first side, I would have x and then minus 3. Right. So, I mean, previously I used to just say you have the same thing in the brackets, take one of the brackets and then take what you have outside, right? Which is, it's also fine. So the answer is 2x minus 15 and x minus 3. That's option A. All right. So question 1 is A. All right, question 2 says, find the quadratic equation whose roots are negative 2 and 7. Okay, so your formula is x squared minus the sum of roots times x, then plus your product of roots. All right, so that's the standard form of a quadratic equation, from the roots, right? So we have x squared minus the sum of roots will be minus 2 plus 7 x, and then the product of the roots would be, well, minus 2 times 7. So we end up with x squared minus 5x minus 14, I believe, right, is equal to 0. So we'd have x squared minus 5x minus 14 is equal to 0. Right, so it's x squared minus sum of roots times x plus product of roots is equal to 0. So the correct option is option A. All right, option A is the correct option, for that. Okay, so that's for question 2. Let's take question 3. Find the equation whose roots are 2 and negative 3.5. All right, so our formula is x squared minus sum of roots times x plus product of roots is equal to 0. Okay, so we're going to have x squared minus, so the sum of roots is 2 plus minus, so 2 minus 3 whole number 1 over 2 times x, then plus products of roots will be 2 times negative 3.5. Okay, so let's do the sum here. So that will be 2 over 1 minus, if I rewrite that, that will be 7 over 2, right? So the LCM is 2. 2 in 1 is 2 times 2, that's 4. 2 in 2 is 1 times 1, that's 7, so that's minus 7. So I'm getting negative 3 over 2, right? So I have x squared minus, negative 3 over 2 times x, Then let's take on the product, right? So for the product, I would have 2 over 1 times negative 7 over 2. So 2 cancels out 2, I'll end up with negative 7, right? So this would be so plus bracket negative 7 is equal to 0. So this looks like 2x squared, sorry, my bad, just x squared, right? So this is x squared minus times minus is plus 3 over 2x, then minus 7. All right, because plus times minus is minus, right? So the next thing to do is to just leave it in the proper form. We'll just multiply the whole thing by 2, right? Multiply the entire equation by 2 to get rid of the denominator here. So we'll have 2x squared plus 3x minus 14 is equal to 0, right? So I multiply the whole thing by 2. So the correct option is option D. Option D, 2x squared plus 3x minus 14 is equal to 0. All right. So it's so important to remember the formula x squared minus open bracket sum of roots x plus open bracket, product of roots is equal to 0. Okay, that's it for question 3. Let's take on question 4. So question 4 says, what value of k makes the given expression a perfect square? All right. So what is a perfect square? Well, a perfect square trinomial is one that factors into, well, in this case, I can say m minus a all squared, right? Something like that, where a is a constant, right? Okay, so for it to be a perfect square, the rule is that the value you have for c, right, must be equal to b over 2 all squared. That's a single rule, right? Very simple rule. So the value you would have here, in this case our k, must be b over 2 all squared. All right, so that means c would be minus 8 because this is b, right? B is minus 8, so minus 8 over 2 all squared give me minus 4 all squared, which gives 16. So the answer is B, 16. All right. So to check out what you should have, right, is that if a is 1, to make it a perfect square, right? So if a is 1, as you have it in this case, then your value for c must be equal to b over 2 all squared. All right. So if a is 1, your value for c must be b over 2 all squared. Okay, so let's take on question 5 now. Find the quadratic equation whose roots are that. Okay, find the quadratic equation whose roots are 3 and 2 over 3. So our formula is x squared minus open bracket sum of roots close bracket x, then plus product of roots is equal to 0. All right, so let's set up the sum. So this will be x squared minus, well, 3 plus 2 over 3 x, all right, then plus 3 times 2 over 3 is equal to 0. All right, so let's work out the sum. That will be 3 over 1 plus 2 over 3. The LCM here is 3. So this gives me 9 plus 2, giving 11 over 3, right? So you would not have been wrong to just say, 3 whole plus 2 over 3 is 3 whole number 2 over 3, right? But again, it's also good to just, run through the process, but it's the same thing. All right, but I'll rewrite this as x squared minus what? 11 over 3x, then plus, so let's multiply this now. So for product, yeah, so we're going to have 3 times 2 over 3, yeah? All right, if I cancel this out, I'll be left with 2. So the product is 2, so that's times 2 is equal to 0. Right, so to get this in the proper form, what we do is just to get rid of the denominator here, we're going to multiply the whole thing. Usually we multiply by the LCM of all the denominators, but seeing that the denominator is only 3, we multiply the whole thing by 3. All right, so let's expand that. We'll have 3x squared minus 11x plus 6 is equal to 0. So 3x squared minus 11x plus 6 is equal to 0. All right, so that's this. C, right? C is the correct answer. So 3x squared minus 11x plus 6 is equal to 0. Okay, that's for question 5. All right. Question 6 says, which of the following is a root of the equation? This, right? So which of this is a solution to that? So we have x squared plus 6x is equal to 0. All right, so what we can do here is I would factor out x. I would say x bracket x plus 6 is equal to 0. All right, so if the two factors here multiply themselves to give 0, it means that one of them must be 0, right? So it's either x is equal to 0, that's the first solution, or, well, if x plus 6 is equal to 0, x is equal to minus 6. So your two solutions are 0 or minus 6, which we have 0 there as option C. All right. Another way to confirm the answer is that you could just plug 0 in rather, and then you would get, you find out that both left-hand side and right-hand side are the same. The roots of the quadratic equation in x are minus m and 2n. Find the equation. Okay, so the formula for using the roots to form the quadratic equation, right? If you want to represent the quadratic equation in terms of the root, you would have x squared minus the sum of roots times x, then plus the product of roots is equal to 0. All right, so we'll just represent this in there. So we'll have x squared, then minus. So the sum of roots would be minus m plus 2n, right? That times x, so that's the sum of the roots. Then plus the products of the roots would be minus m times 2n. So minus m times 2n, is equal to 0. So we'll have x squared minus, so I can write this as 2n minus m, all right? So let's see if that's the form they represent it in. And then, but this one will just be minus 2mn is equal to 0, all right? So looking at the option, we can eliminate C and D because it says plus 2mn. It's supposed to be minus 2mn, right? Considering the other options, we have, so the correct option is option A, right? And the reason why is because, sorry, is that A or B now? Oh, sorry, the correct option is option B rather, my bad. So the correct option is option B, right? And I want to show you that this and these are the same. All right, so that and that, they are the same because if I factor out -1 from here, right, it becomes this. So the plus sign will become the negative sign outside, right, when I factor out minus sign from here. So if I factor out plus outside, right, if I factor out negative minus sign, then in the bracket, I will now have minus 2n plus m times x, all right, which is exactly what we have here. Okay, so yeah, so the correct option is option B. All right, just to make it lay a bit of emphasis, right? If you see something that looks like a minus b, all right, is exactly the same thing as minus what? Minus b minus a. Okay, minus bracket b minus a. So if I factor the negative sign, it kind of means that these two switch roles, when it comes to subtracting. So that's just something to hold on to, right? Okay, so that's the correct option for that is B. Next, we have question 8. The roots of a quadratic equation are -1/4. So we can say alpha is -1/4. And then we can say beta is 3, right? And we're trying to find the original equation. So the rule we have is that the equation would be x squared minus um, sum of roots times x plus product of roots is equal to 0, right? So x squared minus sum of roots x plus product of roots is equal to 0. So this is something that we must learn, right? You must master the formula, right? So that means that for this particular question, we would have x squared minus the sum of roots here is negative 1 over 4 plus 3 over 1, right? X. Then the product of roots is negative 1 over 4 times 3 over 1, all right, is equal to 0. So we're going to have x squared minus, okay, so let's add this up. Negative 1 over 4 plus 3 over 1. LCM is 4, all right, so 4 divided 4 is 1, then times 1, that's negative 1, right? So just negative 1, then plus 4 divided by 1 is 4, then times 3 is 12. So we're going to have minus 1 plus 12, which is 11 over 4. So this is for the sum, right? So for the sum, we have 11 over 4x. Then plus for the product. So for the product, we have negative 1 over 4 times 3 over 1, which would be just, negative 3 over 4, right? So plus negative 3 over 4 is equal to 0. So this becomes x squared minus 11 over 4x plus, sorry, minus, right? Plus times minus is minus. So minus 3 over 4 is equal to 0. All right, so this is the equation. But typically, we like to have our standard form without fractions, right? Without denominators. So we'll multiply everything by the LCM of the denominators, which is 4. The reason why we're doing that is so that we can get rid of the denominators. So multiply the whole thing by 4 and we would have 4x squared minus 11x minus 3 is equal to 0. All right, so 4x squared minus 11x minus 3 is equal to 0. That's option C. All right. So question 9. Find the roots of the equation, and we have that. So find the roots of the equation, and we have that. We have y is equal to 3x squared plus x minus 7. Okay, so you could try factoring, but factoring wouldn't work because when you multiply a by c, you have negative 21. Right, and there's no pair of numbers that would multiply to give 21, but then add to give 1, so it wouldn't work. So we are stuck with either options of using the quadratic formula or completing the squares. All right, so I'll go with the quadratic formula. The quadratic formula is x is equal to minus b plus or minus square root of b squared minus 4ac over all over 2a, right? So again, another formula you must memorize. All right, so a is 3, b is 1, and then c is negative 7. All right, so let's drop it in. We'll have x is going to be equal to minus 1 plus or minus the square root of 1 squared minus 4 times 3 times minus 7 over 2 times 3. All right, so I would have minus 1 plus or minus, this is the square root of 1. 4 times 3 is 12 times negative 7, that should be negative 84, right? So negative 84 times the minus sign here gives you plus 84, then all over 6. So we'll end up with negative 1 plus or minus square root of 85 all over 6. So we really just need to calculate negative 1 plus root 85 over 6 and negative 1 minus root 85 over 6. All right, good. So I have my trusty calculator here. So I have negative 1 plus square root of 85, close that bracket, then divided by 6. So I have 1.36 1.369, so let me say 1.37, and checking on the other, if I change that to a minus sign in the middle, we have negative 1.70, negative 1.70. So I'm looking at 1.4 and negative 1.7, right? So this can be rounded to 1.4. So our correct option is option C. All right, our correct option is option C. All right, that's it for question 9. Let's take on 10. Question 10 says, what must be added to x squared minus 3 to make it a perfect square? What must be added to x squared minus 3? Sorry, x squared minus 3x to make it a perfect square. So we have x squared minus 3x to make a perfect square. What do we need to have here, right? So if you study your perfect square trinomials, right, you realize that the value you have here, all right, which is, well, c as we'd call it, right, your c is always equal to b over 2 all squared. All right, b over 2 all squared. So b is equal to negative 3. So c would be negative 3 over 2 all squared. All right, that's going to be 9 over 4, positive 9 over 4, right? Because minus times minus is positive, so positive 9 over 4. Now is a perfect square, and so that means the correct answer is option C. Yes. Let's take on the next one. All right, question 11 says, adding 42 to a given positive number gives the same result as squaring the number, find the number. Okay. So, I mean, in exam conditions, you actually could test, right? And if you test that, I believe the answer is 7, right? Just 42 plus 7 gives 49, and the same thing as squaring 7, right? But let's try to run through the math. So, we have 42 plus x, all right, gives you x squared. That's the statement. Adding 42 to a given positive number, that's 42 plus x, gives the same result as squaring the number, right? So it's equal to the same thing as squaring x, the number the number in question, right? So we can move everything over, make it like a standard quadratic equation. We have x squared minus x minus 42 is equal to 0. All right, so I believe this can be factored. All right, so we need to find two numbers that add up to give us b, or multiply to give us a times c. All right, b is negative 1, but then multiply to give you negative 42. Wow. Okay, so the numbers have to be, I believe the numbers should be negative 7 and positive 6, right? So those are the two numbers that would satisfy that. All right, so going by that, we can come in and plug this in. We'll have x squared. Then in place of the minus x here, we'll replace it with negative 7x and plus 6x. Then minus 42 is equal to 0, right? Minus 42 is equal to 0. I'll factor out, each section. From the first section here, I can drag out x. So I'll have x bracket x minus 7. And then from the other part here, I'll drag out plus 6 bracket x minus 7. All right. So since we have x minus 7 here and x minus 7 here, that means that we can go on and factor x minus 7. All right. If I factor out x minus 7 from the entirety of this here, from the first bit, I will have just x left, and from the second bit, I will have 6. All right, is equal to 0. So we have this, where we would like to be, where we have the products of two factors giving you 0. And the only way that can happen is if one of them is 0, right? So if x minus 7 is equal to 0, that means that x will equal 7. Or if x plus 6 is equal to 0, that means x would equal negative 6. All right, so the correct options are negative 6 and 7, right? Or 7 and negative 6. But you see, the question already came and said that it's to a given positive number. The question did say that. That means that we cannot even consider the negative solution. The answer is obviously x is equal to 7. Right. Question 12 is asking us to do to solve x squared plus x minus 2 over 2x squared plus x minus 3. And we asked to solve for when x is equal to -1. Right, so we'll just plug in, right? I would have -1 squared on top, plus -1, then minus 2 over 2 times -1 squared plus -1 minus 3. So the top gives me, numerator gives me 1 minus 1 minus 2. All right. Denominator gives me, so 2 times 1 minus 1 minus 3. All right. So my top leaves me with minus 2 because 1 and minus 1 just cancel out, right? My bottom leaves me with 2. 2 minus 1 is 1. 2 minus 1 is 1. And then 1 minus 3 is -2. Right? So the answer is -2 divided by -2, which just gives you what? 1. The correct option is option C. All right, question 13 says, expand the following. Expand the expression. Okay, so there are two ways to do this, right? You can actually do the regular expansion, but then you could also just notice that it's difference of two squares, because we have some variation of p minus q, yeah, times p plus q here, which means your answer has to be some form of p squared minus q squared. All right. So that means if you compare it to this, because 3a is our p, and then xy is our q, right? So if you want to rewrite this way, it's going to be 3a all squared, right? Then minus q, which is xy all squared. So the answer will be 9a squared minus x squared y squared minus 9a squared minus x squared y squared. That's option C. Question 14 says expand 2x minus 3y times x minus 5y, right? So we'll just expand them carefully. We have 2x minus 3y multiplying x minus 5y. Okay. So I'm going to say 2x times x here gives me 2x squared. And then 2x times minus 5y would be minus 10xy, right? Minus 10xy. Minus 3y times x would be minus 3xy. And then minus 3y times minus 5 would be plus 15y squared. Okay. So we have like terms in the middle, we can put that together. So the correct answer should be 2x squared minus 13xy plus 15y squared. All right, so 2x squared minus 13xy plus 15y squared. That's option A. All right. Question 15 says, okay, question 15 says we have to expand, you know, product of two binomials, right? So we have 2x minus 5 multiplying x minus 3. All right. So I'll start by taking the first term here and multiply everything in. Okay, so 2x times x gives 2x squared. 2x times minus 3 gives minus 6x. Minus 5 times x gives minus 5x. And minus 5 times minus 3 gives plus 15. Right? So we have like terms in the middle that we can put together. So we're going to have 2x squared minus 6x minus 5x gives you minus 11x. Right? And then plus 15. So the correct answer is option C. Option C. All right, question 17 says we are to factorize 3a squared minus 11a plus 6. 3a squared minus 11a plus 6. All right, so let's write that here. 3a squared minus 11a plus 6. All right. To factorize a quadratic expression, the two terms in the middle, the product of the two terms in the middle must be the same as the product of the two terms at the other end, right? So the way we try to remember that, what we're supposed to say, okay, b and then ac. So our b is -11,
and our AC is 18, right? So we need to now think of two numbers that will multiply to give negative 11, add to give negative 11, right? Because you're going to be replacing this, but then multiply to give 18. You can list out the factors of 18, but the correct values are negative 9 and negative 2, because they add up to give you negative 11, but also multiply to give you positive 18. All right, so I'm going to use those numbers to replace the 11a. So I'll have 3a squared minus 9a minus 2a plus 6. All right. Next comes the factoring. We're going to do the grouping thing, right? So what can we drag out from the first set? We can drag out 3a. All right. 3 is common to both of them and also a. If I factor out 3a, in the first group, I'll be left with just a. Or in the first from the first term, I'll be left with just a. And then from the second term, I'll be left with negative 3. All right. From the next set, minus 2a and plus 6, I can factor out negative 2. And when you check the bracket, you'll be left with a and minus 3. Okay, so now that we have these things in the bracket the same, we can go on to factor out a minus 3 from the entire system. If I factor out a minus 3 from the first group here, I'll be left with just 3a. And from the second group here, I'll be left with minus 2. Right, so here you go. We have set up the system, right? It's 3a minus 2 and a minus 3. The correct option is option A. All right, so 18 says factorize completely. We have x squared minus open bracket y plus z all squared. All right, so this is actually difference of two squares. Difference of two squares states that if I have p squared minus q squared, all right, I can write it as p plus q times p minus q. All right. By comparison, you can see it's exactly the same thing. The only difference is that your p here is x squared and your q is y plus z. All right. But let's apply it. Let's apply it. So it's going to be p, which is x. All right. Then x plus q. So x plus y plus z. Then multiplying p minus q, that will be x minus y plus z. All right. Okay, good. So what we'll have here from the first will be x plus y plus z. Then what we'll have here will be x minus y minus z. Right. So x plus y plus z and x minus y minus z. The answer is option B. Factorize completely that. We have to completely factorize that. So 6ax minus 12by minus 9ay 8x. All right. So they need to be arranged in such a manner that the product of what you have in the middle will be the same as the product of what you have in the end. At the end, that means that this times this, right? This times this must equal this times this. Just by looking at it, you can see that it's not properly positioned, right? So we need to do some rearranging, and there are a number of ways you can do that. But I'll just switch this and this. All right. So let's try that and see. So that will be 12 times 8 and 6 times 9. No, that wouldn't work. Let's do okay, good. So let's do 9 times 8. Okay, good. So let me write it this way, because then we can have 22 AYBX, right? So if I do minus 9 AY, then I'll push this 2 to the middle, plus 6AX minus 12 BY, right? And plus 8BX. Okay, so it's positioned in such a manner now that, you know, what we have at the end is the same product as what we have in the middle. All right. Maybe just to make sure I don't have a negative sign in front, I can also switch minus 9, right? Like the last term and the first term. Again, we can work either way, right? But I'll switch it. So we have 8bx then I'll put the two middle terms, plus 6ax minus 12by and minus 9ay, right? So from what we have in the middle here now, I can factor out 2 and x, right? And what will be left here will be 4b rather, right? So 4b plus 3a, right? So 4b plus 3a. And then from here, I can factor out negative 3y, right? So that will be negative 3y, right? Negative 3y, I'll be left with 4b plus 3a, right? So since we have the same thing here and here, right, that means we can regroup, right? So that means we can factor out 4b plus 3a from both terms, right? I'll factor out 4b plus 3a, and then I'll be left from the first part, I'll be left with 2x, and from the other side, I'll be left with minus 3y. So we should be looking for something that looks like this, that tells the story 4b plus 3a, all right, and then 2x minus 3y. So I think the correct option is option C. Okay. So when the whole idea is that when you're grouping, right, you should make sure that you have the product of the terms in the middle must be the same as the product of the terms, at either end. Yeah, and then you can go on to do your grouping. Okay, that's for question 19. For question 20, we are asked to factorize the expression. So we have x bracket a minus c and plus y bracket c minus a. Okay, so the issue we have here now is that what we have here and what we have here are not the same. All right, but one very easy thing to do is we can factor out -1 from either of them and they'll be the same. So you need to recognize that b minus a is the same thing as minus what? A minus b. All right, so again, you can write this down, try to interpret it again and again, makes sense. But if you have a difference of two terms, right, in a binomial, then, if you factor out a -1, then the two terms are reversed, right? And you can expand it, you see it's true. Okay, so that means I can factor out -1 from this guy here, right? Factor out -1, and then this end will now become minus y bracket a minus c, all right? So just like the other one, right? So I have x bracket a minus c, and then by factoring out a negative sign from here, I have minus y bracket a minus c. So we end up with, we can factor out a minus c, so a minus c can be factored out, and then we'll be left with x minus y. So we are looking for a minus c and then x minus y, that's option C. All right. So yeah, so it's just this trick here, right, that we need to pay attention to. And another person, I mean, you could walk through this by just, you could expand everything and then rearrange it and then factor, right? So you could expand what we have. Let's solve it that way. You could have, we have x bracket a minus c plus y bracket c minus a, and then you could choose to say, okay, ax minus cx plus cy minus ay. All right, and then when we go back to our rule, the rule is that the product of what you have in the middle must be the same as what you have at the end. Does that work right now? No, I don't think so, right? So we need to switch positions we can switch the positions of the final two terms. So you can have ax minus cx minus ay plus cy, right? So now we can factor. I can factor out x from here, x bracket a minus c, and I can factor out negative y from here, and I'll have a minus c also, right? So again, same thing. So again, same thing, right? But I mean, this took time. With the first method, with method one, I could solve this without even, without even actually solving, right? Like by just looking at the question, I could tell the answer. Okay, right. So that's for question 20. Let's go question 21 now. Sorry, 1 second. So yeah, 21. Okay, so question 21 is saying factorize the expression that, right? Factorize the expression that, and we are asked to factorize 2s squared minus 3st minus 2t squared. All right. So we know that for us to be able to factor, we need to have two terms in the middle. All right. So we need to split up the term in the middle into two. And the goal is that the product of the two terms in the middle will be the same as the product of the terms at either end, right? So what's my b? Just comparing it to a quadratic equation, right? What's my b and what's my ac? My b is -3 and my ac is -4. So what are the two values that we could use to that would multiply to get -4 but add to get -3? We need to think of two values that we can add to get b and multiply to get ac, right? So the two values have to be -4 and +1, right? And so we can use that now to replace this guy here. So we're going to have 2s squared rather, minus 4st plus st minus 2t squared. Okay, so now that we've done that, you can check and you will see that the product of the terms at the end is the same as the product of the two terms in the middle. All right, so now we can go on to factor. Um, 2s is available here, right, in both of them. So we can factor out 2s. So to be 2s bracket s minus 2t right here. And here we can factor out t plus t and we'll have s minus 2t also. All right. So that means that since we have the same thing here and here, we can actually group, right? So we can factor out. I'll factor out s minus 2t. All right. And then from the first group, I'll have 2s, and from the second group, I'll have just plus t. We are looking at s minus 2t and 2s plus t. I think that's option D, right? I think that's option D. Okay, that's for question 21. Let's take on question 22. Question 22 says factorize the expression 2y squared plus xy minus 3x squared. So we have 2y squared plus xy minus 3x squared. All right. So the goal is to ensure that for you to be able to factorize the quadratic expression, right? We need to split this, the middle term into two, such that the product of the two terms in the middle is same as the product of the two terms at the end. And then those two terms, of course, must add to the middle term because we don't want to change the expression, right? So what we'll do is we'll write out what the coefficient of the middle term is, typically called b, and then the product we like to achieve, the coefficient of the terms at either end, ac. Right, so the coefficient of the term in the middle is 1, that's b, that's 1. And then the coefficient of the term, the product of the coefficient of the terms at either end, right, that's 2 times -3, that's -6. So the question now is, can we find two numbers that will add up to give us the value of b, and then multiply to give us the value of ac? I think we can, right? Those two numbers will have to be 3 and -2, all right? 3 and -2, so that means that this guy here becomes 2y squared plus 3xy minus 2xy minus 3x squared. Okay, and you can test the product of the terms in the middle is same as the product of the terms, the terms at the end. So the product of the terms at the end here will be the same as the product of the terms in the middle. All right, so with this now, we can now start the grouping process. Split in two. All right. From the first group, I can drag out just y, right? That's the only thing common to the first two terms. So I'll be left with 2y in the middle. No, 2y. When I factor out y from 2y squared, I'll have 2y and then plus 3x. All right. And then from here, I can factor out minus x. Okay, so I can factor out minus x, and I would have 2y plus 3x. So as a rule, I always factor out the negative value from the first term, right? So from the first term in each group or in each pair, right? What that does is it allows me to ensure that it's the way it's supposed to be. All right. So I have the same thing here and I have the same thing here. So that means I can go on to group. Right. So I can factor out 2y plus 3x. And then when I factor out 2y plus 3x from the first term here, right, I'll be left with just y. And when I factor out 2y from the 2y plus 3x from the second term here, I'll have minus x. So we should be looking at something that says y minus x and then 2y plus 3x. Okay, that's option B. Yeah, that's option B. So that's question 22. All right, so let's go on to question 23. We are asked to factorize the following expression. Let me do this here. Sorry. So I have 2x squared plus x minus 15. 2x squared plus x minus 15. All right. And the rule for factoring is that we need to have the two terms in the middle. We need to set up two terms in the middle, right? Such that the product of those two terms is the same as the product, of the terms at either end. All right. So I like to write my BAC, B and then AC. Right? What's the value for B? Value for B is 1. Then the value for AC is 2 times minus 15, that's minus 30. Right? So coefficients A, B, which is 1, and then C, right? So we need to find two numbers that add up to give us, the value for B and multiply to give us the value for AC. Those two values have to be 6 and minus 5, right? 6 and minus 5. Yes, 6 and minus 5. Okay, so we'll come back here and then use those two values to replace, the middle value here, the B term here. So we'll have 2x squared plus 6x minus 5x minus 15. All right, so we are set. And you can test it, right? The product of the terms at the end point, right? 2x squared and minus 15. Their product will be the same as the product of the terms in the middle. All right, so we can begin our grouping process. I can drag out 2x from here, right? 2x, and then I'll have 2x bracket x plus 3, all right? And then from the second group here, I can drag out negative 5. So I always just factor out the negative number, right? So it just such that if I ever do find a negative number, I factor it out. So I'm factoring out negative 5, and here I'll have x plus 3. So always factoring out the negative number, what it does is that it ensures that, there's a standard of sorts. You won't have issues where you feel like you've done everything properly, but the terms and the brackets are not the same. You won't have such issues if you learn to just if the first term in each group has a negative number, I'll factor out the negative sign also. Okay, so this then becomes we can factor out x plus 3. So x plus 3 times from the first group here, when I factor out x plus 3, I'll be left with 2x. From the second group here, when I factor out x plus 3, I'll be left with negative 5. So we have x plus 3 and then 2x minus 5. X plus 3, 2x minus 5, that's option D. That's option D. All right, so question 24. Question 24 says we should rewrite or factorize m bracket 2a minus b minus 2n bracket b minus 2a. Good. Okay, good. So this is very neat, right? This is very neat. It would have been really easy if we had the same thing in the brackets, right? But we don't. Okay, but you can easily do it by just recognizing that b minus a, all right, is equal to minus a minus b. So if you ever find yourself at the point where you probably have maybe something, maybe p minus q, but what you need to operate is q minus p, you can easily make this transformation, right, by just factoring out negative 1, factoring out a negative sign from the group. So I'm looking at this now and I'm like, okay, I want to make this 2 minus b. So I just factor out negative 1. So that means that this whole thing, right, this expression can be written as m bracket 2a minus b, then minus 2n, factor out minus 1, then this now becomes what? 2a minus b. So this is something you need to practice, right? You need to practice because when it pops up, it's you might, if you've not practiced it, you won't recognize it. Okay, so we have m bracket 2a minus b, then plus 2n bracket 2a minus b. Now we have the same thing in each group. All right, it's easy for us to just factor out 2a minus b and then be left with what? M plus 2n. All right, so m plus 2n and 2a minus b, that's option D. Okay, so that was easy enough, right? But one could say, I mean, if you had to expand, you wouldn't be wrong. You're good. All right. So if you had to expand, so you wouldn't be wrong, right? So you could have chosen to say, okay, I have m bracket 2a minus b, then minus 2n bracket b minus 2a. All right. If I expand this, I'll have 2am minus bm minus 2bn plus 4an. All right. So that's it factorized right there. Yeah. The next thing is we would need to rearrange it, right? We would need to rearrange because it's not arranged in a manner that, the product of the terms at the end is same as the product of the terms in the middle. So I can easily sort that out by switching these two terms, right? Just switching them up. And then we would have it such that the product of the terms in the middle is same as the product of the terms at the end. So I'll have 2am minus bm plus 4an and then minus 2bn. All right. So we can factor out now, right? We can factor out. From the first, I just have m, so I'll factor out m, and I'll have 2a minus b. And at the end here, I can factor out 2n. Yes, I can factor out 2n, and I'll be left with 2a minus b also. Good. So we can just factor out 2a minus b, and then we'll be left with m plus 2n, all right? Because now we have the same thing here. We can drag out 2a minus b here, and then from the first group we'll have just m left, and then from the second group we'll have 2n. So the answer is D. Okay, so but I personally prefer method 1, and I think it's just a nice trick if you learn to just recognize this this fact, right? And also because it might have applications outside of just factoring. So and it's faster, I mean, I could actually, if not that I was solving this out to teach, I could actually look at this and tell you the right answer without even putting pen to paper. Right? So that's question 24. Take that out. And then let's go 25. Right? So 25 is asking us to factorize that. We have to factorize 27 p squared x squared minus 48 y squared. Okay, so the first thing I'll do is, I know I can factor out 3 at least, right? So I'll factor out 3 and I would have 3 brackets 9p squared x squared minus 16y squared. All right, and then looking at it, we can see there's obviously difference of 2 squares. All right, difference of 2 squares simply says that if you are ever stuck with a scenario that is a squared minus b squared, all right, wherein both of these are perfect squares, then you can rewrite as a plus b multiplying by a minus b. All right, so that's difference of 2 squares. It's just a neat trick that helps you factorize faster. So I have my 3 here, and then in here, of course, it's difference of 2 squares, right? So if a squared is this, that means a is just 3px. All right, so I will have 3px plus square root of that is square root of that is 4 y, then 3px minus 4y. All right, so that's how it works. So this just is 3 bracket 3px plus 4y, then times 3px minus 4y. All right, so that's option D. Yes, that's option D. That's for 25. So let's take on 26. 26, we have factorize 2e squared minus 2e plus 1. Sorry, so we are asked to factorize 2e squared minus 3e rather, right? Then plus 1. Okay, we need to rewrite this in such a manner that the values in the middle, all right? We need to rewrite the middle term, make it 2 values, such that the product of the values in the middle will be the same as the product of the values at the end, right? So just to simplify that process, right? we write b and ac. B is -3 and then AC is +2, right? So we need to find two numbers that add to give you B and multiply to give you AC. Those numbers have to be -1 and -2, all right? They multiply to give you +2, but add up to give you -3. All right, so we can come here and, fight this, right? So this becomes 2e squared minus e minus 2e plus 1. All right. So from where we are now, we can just make progress. Split them in two. Let's factor out from the first group. From the first group, I can drag out e, right? So I'll drag out e. This will be e bracket 2e minus 1, right? And then from the second group, I can factor out -1, right? So -1, then bracket 2e minus 1 also, right? Because if I divide +1 by -1, I would have -1 left, right? So we have the same thing in both brackets. So that means we can factor out the 2e minus 1 itself. And then from the first group, we'll be left with e. From the second group, we'll be left with -1. So the answer is 2e minus 1 times e minus 1. That's option D. I think we've had option D like 3 times in a row now. We have it a 4th time then. Okay. So question 27 says factorize 32x cubed minus 8xy cubed. All right. So just by looking at it, I know I can factor out 8x, right? I can factor out, xy squared, my bad, sorry. So I know I can factor out 8x, right? 8x is common. So let's drag out 8x. We'll have 8x, then in brackets here, we'll have 4x squared and then minus y squared, right? Look at this guy in the middle. Not in the middle, rather in the bracket. You will see it's difference of two squares. Difference of two squares simplifies the factorization of a squared minus b squared terms, right? Anything that looks like this, where you have one square number subtracting another square number, or expression rather. So one square term subtracting another square term, you can rewrite it as a plus b multiplying a minus b. All right, so it's very simple. So this 8x is out here. So my job now is to rewrite what I have in the bracket as a plus b, a minus b. So if a squared is 4x squared, that means that a itself has to be 2a and 2x. All right, so that means the square root of this is 2x, then minus the square root of that is y, right? Then that would now multiply 2y plus 2x plus y. All right, 2x plus y. Okay, so that's it. Difference of two squares. That the answer will be 8x bracket 2x minus y multiplying 2x plus y. So difference of two squares is something that you must learn. It shows up, right? It always shows up. So you just want to be able to spot it and then know exactly what to do with it. All right, and it's very simple. If you have a difference of two terms, two expressions, then you can write them out as the product of the sum and then the difference between the two terms. Okay, so again, 8x bracket 4x squared minus y squared. I will rewrite this as 8x. So let me put that away. Square root of this is 2x minus y times 2x plus y. Very simple, right? So the correct option is option A. Correct option is option A. That's 8x, 2x plus y, 2x minus y. All right. 28 says 35 minus 2b minus b squared, right? So 35 minus 2b minus b squared. Okay, so we can still proceed, right? We don't have to. I mean, you could choose to rewrite it in the what now? In the standard form as it were and start with minus b squared. but but um but there's no problem with that, even if you decide not to do it that way. All right, so we'll just follow through with the same rules. All right, so I'm going to have was my B and then was my AC. My B is -2, and then the products of the terms at either end is minus 35, right, of the coefficient. So that's minus 35. So we need two numbers that will add up to give us -2, but multiply to give negative 35. Those numbers have to be -7 and +5, right? So numbers that will add up to give us -2 and multiply to give us that. Okay, so I would use these numbers to replace, the middle value. So I would have 35 minus 7b plus 5b minus b squared. All right. And by replacing them, we have not changed the equation because I can put my -7b and 5b together and still get, the same thing, right? It still give me -2 if I add them up. So we are good. All right. Next thing is we split up. What can I factor from here? I can factor out 7, right? I factor out 7 here, I would have 5 minus b. Yeah. And from here, I can factor out 5. And I would have, sorry, I can factor out b, b, and I'll have 5 minus b also, right? So because I have 5 minus b both sides, I can factor it out. And then from the first bit, I'll have 7. From the second bit, I would have, plus b. So the correct answer is 7 plus b, 5 minus b. That's option C. All right. So again, you could choose to rewrite it backwards, right, as minus b squared minus 2b plus 35. All right. The only thing is don't mess up the signs. All right. Don't mess up the sign and say, oh, I'm dividing through by -1. You can't do that because this is not an equation. If it was equated to 0 and you wanted to divide through by -1, that's fine. But if it's not equal to 0, you can't do that, right? Because you are altering it. So unless you want to maybe factor out -1, keep it out there while you work on whatever is going on inside, that's your choice. But I'll just walk straight up, right? So do the same thing again. B and then AC. My value for B is -2. The product is -35. So the two numbers that would work would be -7, right, and +5. So I can rewrite this here. Sorry about the long lines, right? Rewrite this here by splitting up -2b into minus b squared minus 7b plus 5b plus 35. All right. So for the first group, I'll factor out the negative sign, negative b, then I'll have b plus 7. All right. And then from here, I can factor out +5, and I'll have b plus 7. All right. So I can factor out b plus 7, obviously, right? And then I'll be left with minus b from the first group here, and then +5 from the second group here. So again, pretty much the same solution, right? Same thing. All right, that's it for question 28. Let's take question 29. All right, so question 29 says, so question 29 says we should factorize 5y squared plus 2ay minus 3a squared. Okay, so to be able to factorize this, we need to rewrite term in the middle. All right, we write our b and then AC. Our b is +2 and a times c is -15. All right, next we need two terms that would multiply. Their product would be the same as a and c, and then their sum would be b. All right, so those two terms have to be +5 and -3. Right, and we can use them to replace b here. We can use them to replace b. So we'd have 5y squared plus 5ay minus 3ay minus 3a squared. Okay, so what we've done now is we've been able to successfully rewrite the equation, and it's the same exact expression, right? Because if I put in the two terms together, if I add them together, right, I'll still get 2ay. So I have not changed the expression in any way, right? But what I've done is I have rewritten it such that the product of the terms in the middle is same as the product of the terms at the end. And since we have that now, we can go on to factorize by grouping. All right, so I'll split this up. From the first bit here, I can factor out 5y actually, right? Yeah, 5y. And then I'll be left with y plus a. Um, um, from the second group here, I can factor out -3, right? So I make it a point of duty that, -3a rather, I make it a point of duty that if I have a negative sign as the leading term, right, in either of the two groups, like I just separated them, I factor out the negative sign also, all right? So I would have y plus a also, okay? So we can see we have y plus a in both of them. So we can factor out y plus a itself, all right? And then, so factoring y plus a from the first group here, I'll be left with 5y. And then factoring y plus a from the second group here, I would have -3a. So we need the option that says y plus a and 5y minus 3a, and that's option C. That's option C. Okay, for question 30, we have 6x squared plus 7x minus 20. Okay, so we have 6x squared plus 7x minus 20, and we are asked to factorize. Okay, so to factorize this, we need to rewrite the middle terms here, right? We need to rewrite this middle term such that the two middle terms, the product of the two middle terms will be the same as the product of the two end terms. So like 6 and minus 20. Anyway, there's a fast rule, right? Just write B and AC. B is 7, right? That's the coefficient of the middle term here. And then A times C, this is A and this is C, right? A is 6 and C is minus 20. So A times C gives you minus 120. So your job now is to look for two numbers that will add to 7 and then multiply to give negative 120. What are the factors of negative 120? We have 10 times 12, that doesn't work. 20 times 6 doesn't work. 15 times 8 should work, right? So 15 times 8 should work. So we would have positive 15 and negative 8. Okay, so they multiply to give 120 and minus 120 and then add up to give positive 7. Great. So we will write this as 6x squared plus 15x minus 8x minus 20. Okay, so we just rewrote the equation the way we want it, such that the product of the two middle terms is same as the product of the terms at the end, but at the same time the two middle terms still add up to give us 7, right? So we have not changed the expression in any way, right, in terms of its value as it were. Okay, so the next job to do now is to factor. So we split in two, and from the first group here I can factor out 3x, right? So 3x, and drag out 3x, and I'll be left with 2x plus 5. All right. From the second group here, I can factor out -4. All right. So I make it a point of duty that if the leading term in either of the two groups now, the two groups of binomials that has been set up, if the leading term has a negative sign, then I factor out the negative sign also. All right. So that ensures that there's a mistake that could occur if you don't have a system around that, and that's the system I choose to adopt. Okay, so I can factor out -4, and I would have 2x plus 5. Okay, so we have the exact same thing in both brackets, such that we can choose to factor out 2x plus 5 from the system. And then, if I factor out 2x plus 5 from the first group here, I would have 3x. And then factor out 2x plus 5 from the second group here, I would have -4. Right, so we are looking for the option that says 2x plus 5 and 3x minus 4. That's option D. That's option D, okay? So let's take on question 31, right? Question 31. 31 says we should factorize x squared plus 4x minus 192. So we have x squared minus 4x, okay, no, plus 4x minus 192. Okay, so for us to be able to factor this, right, we need to have two terms, right? Split up 4x into two terms that would add up to 4x, such that the system is not distorted, but at the same time the product of the two terms will be the same as the product of a and c, right? So here's what I mean. we write B and AC, so it's a nice hack that we use. And then our B is 4, and our A times C is negative 192. Okay, so the next task is just to think of two numbers that will add up to um, 4. That's the value of B, right? But multiply to give the value of A times C. So we need to dig into the factors of 192, and I think we would work with 12 and 16. All right, 12 and 16, because that would be negative 12 and positive 16, right? Because they will multiply to give negative 192, but add to give 4. So we're going to have x squared minus 12x plus 16x minus 192. All right, so the task we have done is to rewrite the entire system such that the middle values are, if I add up minus 12x and add up minus 12x and 16x, it still gives me 4x, right? But I just rewrote it in a manner that we would have, we are able to factor. Okay. All right. So from this, we can drag out x, just x, right? So this will be x minus 12. And from these two terms, you can drag out plus 16, and this will also be x minus 12. So since we have x minus 12 repeating, we can factor out x minus 12 from the entire system, right? And then bringing out x minus 12 from the first group here, we'll have just x left. And bringing out x minus 12 from the second group here, we'll have just 16 left, all right? So that's x minus 12, x plus 16, and that is option C. X minus 12, x plus 16, that's option C. Okay, that's for question 31. Let's go on to 32. 32 says we should factorize 5y squared, okay? To factorize 5y squared plus 2ay minus 3a squared. To factorize 5y squared minus 2ay minus 3a squared. Okay, so we need to rewrite this by separating 2ay into two terms. All right, we separate 2ay into two terms such that for those two terms, their product must give you the same value as the product of the first term and the last term here, right? So you need to find that for you. So that's the rule for grouping, okay? That the two terms in the middle would be the same as, will have the same product as the first term and the last term, all right? So in doing this, there's a nice hack we use. We write B and then AC, so we specify that B is 2, and then A times C is minus 15, right? Because that's 5 times minus 3, right? Minus 15. And now we need to dig for two values, two numbers that would add up to give 2 and multiply to give negative 15. Okay, working around the factors of negative 15, I think those numbers must be 5 and negative 3, right? We can test that. They add up to give positive 2 and then multiply to give negative 15. Good. So this would become 5y squared. Then we pick those numbers and replace b. So plus 5ay minus 3ay minus 3a squared. All right. So from this now we can split them up in two, and then we'll factor each group. So from the first group, I can drag out 5y. All right, and then I'll have y plus a. From the second group, I can drag out negative 3a, right? So if I have a negative leading term or leading coefficient for either of the two groups, I always drag out the negative value, right? Just so that I'm sure of, that there's no error. Because it's possible for you to do everything right, and then if you leave the negative value in there and drag out just 3, what you have in the two brackets would not be the same, right? But I'll drag out the negative 3a such that now when I divide, I'll get y here. When I divide this, I'll get plus a, all right? When I factor out 3a from minus 3a from that. So now, all good. We have y plus a and y plus a. So I can factor out y plus a, all right, itself, because y plus a is present in both terms, right? So if I factor out y plus a, then from this first group here, I would have 5y, just 5y left, If I factor out y plus a from the second group here, I would have negative 3a. So we're looking for the option that says y plus a and then 5y minus 3a. That's option A. That's option A. Okay, so we have that. So let's take question 33 now. So question 33 says factorize 6x squared. So let's do that. 6x squared plus 7xy minus 5y squared. Okay, so to be able to comfortably factor this, I would need to rewrite the middle term. All right, I'll need to rewrite the middle term. So to factorize by grouping, you would have 4 terms, right? And then the 2 terms in the middle, the product of the 2 terms in the middle, so you have 4 terms. The product of the 2 terms in the middle must be the same as the product of the 2 terms at the end. Okay, so there's a neat trick to help us achieve that though, right? We just write B and AC, okay, representing the coefficients of the 3 terms. All right, so B is 7 here, as the coefficient here, and then AC, A is 6 and C is minus 5. So when you multiply A by C, you get negative 30. All right, so the next task now is, can we find 2 values, any 2 numbers that would add up to give B and then multiply to be AC. All right, so I think the factors of 30 that would work, 10 and 3, right? So that'll be 10 and minus 3, because I can multiply that to get minus 30 and then add that to get plus 7. Okay, so rewriting this, I would have 6x squared, and then in place of this 7xy, I write this in, right? So I'll have plus 10xy, right, minus 3xy, then minus 5y squared. Okay, so from the first group, what can I drag out? From the first group, I can drag out 2x, I believe, right? So 2x is common, and in the bracket, I'll have 3x minus plus 5y. Brilliant. Okay, so I just factored out 2x from the first group, and then from the second group, I can drag out negative 1. All right, so sorry, negative 1. I can drag out negative 1 from this set, right? So I would have, sorry, I can drag out negative y. Yeah, negative y. Good job. So I will have 3x, right? And then plus 5y also. Brilliant. Good. All right. So the next step is, seeing that we have the same thing in the brackets, then I can factor out 3x plus 5y. All right. And when I factor out 3x plus 5y from the first group, I would have 2x. When I factor out 3x plus 5y from the second group, I'll have minus y. Okay, so we are looking for the option that says 3x plus y and 2x minus y. So 3x plus y and 3x plus 5y and 2x minus y. That's option D. Yes, 3x plus 5y and 2x minus y. Okay, so we have that. That's question 33. Let's go on to question 34. Question 34 is asking us to factorize this, right? Asking us to factorize x plus y minus ax minus ay. Okay, so the first thing we need to do is we need to check if this is factorizable as is. All right, so for us to be able to factorize this, then it follows that the product of the terms in the middle must be the same as the product of the terms at the end. The product of these 2 terms here at the end, right, must be the same thing as the product of the terms in the middle. And I think it checks out, because if I multiply x by minus ay, I'll get minus, well, you could say axy. And if I multiply y by minus ax, I would also get minus axy. So it checks out. So we can factorize. We don't have to move anything around or rewrite anything. Okay. So start with the grouping step. Split this up. Okay, from x plus y, I can drag out 1. All right, that's the only thing I can factor. So it's going to be 1 bracket x plus y, right? So that's good. From the next group here, I can factor out minus a. All right, factor out minus a, and I would have
x plus y also. Okay, so looking at this, we have the same thing in the brackets, right? X plus y, x plus y. So that means we can factor out x plus y itself. And then if I drag out x plus y from the first group, I would have 1. If I drag out x plus y from the second group, I'll have minus a. So I'll end up with x plus y and then times 1 minus a. X plus y times 1 minus a, that's option D. Okay, question 35 says, factorize completely x plus 2 all squared minus 2x plus 1, then all squared. Okay, good. So these are difference of two squares kind of scenario, right? Where we have a squared minus b squared. All right. I must give you a plus b times a minus b. Okay. So if you compare these to that, that means that a squared minus b squared must give you a plus b. So what is a in this case? That's the x plus 2, right? So we're going to have x plus 2, okay, a plus b, then plus, what's b? B is 2x plus 1, right? Plus 2x plus 1, then all of this, then times, a plus b, a minus b, right? So minus a minus b. So this will be x plus 2 minus open bracket 2x plus 1. So let me also put my bracket here, even though it doesn't mean much though because it's a positive sign, right? But it just allows us to flow. Okay. So I hope this is fine though. Like I hope you're able to see a squared minus b squared here. I mean, it's just, so a is everything inside and then b is everything inside. And so if you do know this formula, then it's easy to just work with it. Okay. And so we now wrote this as a, this is ax plus 2 plus b, that, then multiplying a, then minus all of this is b, right? Good. So let me wipe all of this off and give the whole thing neat. Okay. Okay, so we can do this, right? This would be, sorry, let me continue this here. So this would be x plus 2 plus 2x plus 1, right? Because when positive multiplies in, it stays the same. So positive times positive is positive. Then for the other, we'll have x plus 2. Then when the minus sign multiplies it, we'll have minus 2a minus 2x minus 1. So remember, so minus 2x minus 1, right? Good, because minus times positive is minus. All right, so simplifying this, x and 2x gives you 3x, and then 2 plus 1 gives you 3. So this is 3x plus 3 here, and on this side we have x minus 2x gives you minus x, and then 2 minus 1 gives you plus 1, right? Okay, so we can factor out 3 from this though, right, just to make it look like the options we have. So we have 3 brackets x plus 1. All right, and then for this we can rewrite this as what? 1 minus x. All right, 1 minus x. So the correct option is option A. Correct option is option A. But it's really just difference of two squares. So you need to familiarize yourself with a squared minus b squared if you haven't done so already. You must be able to spot it in different kind of scenarios. All right, so that's for question 35. Let's take question 36. Okay, 36 says we should factorize the expression am plus bn minus an minus bm. Right, so let me write that up here. Am plus bn minus an minus bm. All right. So to be able to factor using the grouping, it must be that the product of the terms in the middle must be the same as the product of the terms at the end. All right, the product of the terms in the middle must be the same as the product of the terms at the end. So the product of the terms at the end, that's this. That's am times minus bm, right? What that gives is that gives you minus abm squared, right? But the product of the terms in the middle, bn minus an, right, multiplying that would give you
abn squared minus. So they are different, right? They are different. So that means that we can't factor this way because the product of the middle terms is different from the product of the end terms. So we can't do that. Okay, so what we're going to do instead is this, right? We'll try to rearrange it. So by simply switching these last two terms here, we should be good, right? I mean, there are other ways you could arrange it, right? I just did that. So we have am plus bn. Would that even work? No, it wouldn't, right? So switching the two here wouldn't work actually, because, yeah, it wouldn't work. Just did it in my head. So let's try switching. Okay, let's switch this two, right? Then we start with a negative coefficient, which of course there's nothing wrong with, right? But just like to avoid. Okay, instead let's switch. Okay. If I put an at the end, I need to have bn. Okay, okay, let me put bn. So bn is okay here. I'll get it shortly. Sorry. Just want to have a negative coefficient at the start out. Okay, so let's try. Oh, okay, so let's try am. Let me just move this to the other end, right? So minus an minus bm plus bn. All right. So let's see how this arrangement works now. Because we have the two middle terms would multiply to give us minus an times minus bm. All right. So if you multiply that, you're going to have abmn. All right. And then if I do for the two ends, so I just did for this two, right? So if I do for the other two, I'll have am times bn, which would give me abmn also. Okay, good. So we're good now. We can factor. All right, you can factor. The product of the two terms in the middle is exactly the same as the product of the two terms at the end. All right. So what can I factor out from the first group? I can drag out a. This will be a bracket m bracket minus n. And then for the other group here, I can factor out minus b. And then that will be minus b bracket m minus n. Right? So whenever I have a leading coefficient that is negative, I always factor it out. Okay? So this would become m minus n and a minus b. All right? M minus n times a minus b. Okay, so and that's because, sorry, just so I don't skip anything, it's been a troublesome question. I have m minus n in both groups, right? So I can factor out m minus n from both of them. All right? Then from the first group, if I factor out m minus n from the first group, what will I have? Just a left. And if I factor out m minus n from the second group, what will I have? Just minus, minus b. So I'm looking for something that says a minus b and m minus n. A minus b and m minus n. So that's option C. 6C. So 37 says factorize, 2x plus 3y all squared, then minus x minus 4y all squared. Okay, so what we're looking at is we're looking at a case of a squared minus b squared, right? So and there's a nice neat rule for that, that a squared minus b squared is going to give you a plus b multiplying a minus b. So this holds for whatever a or b could be. All right, so this is called difference of two squares. That when you have two square expressions, subtracting themselves, then the answer you will get will be the product of their sum and their difference. Okay, so looking at this, a is what we have, of course, inside the bracket, right? So I can express this other side as, for my a plus b to be 2x plus 3y, then plus my b value is what I have inside here, right? So plus x minus 4y, all right? This is a plus b. Then for a minus b, I would have, again, what I have in here, 2x plus 3y, then minus my b value, what I have in here, x minus 4y. All right, so for the first group, I'll just have 2x plus 3y plus x minus 4y. All right, for the second group, I would have 2x plus 3y minus x plus 4y. Okay, because that minus sign here is multiplying, into the whole thing, right? Okay, so we can simplify both brackets. We'd have 3x minus y. All right, that's what we have in the first bracket, plus 2x plus x is 3x, and then 3y minus 4y is minus y. Great. And then here we have 2x minus y, 2x minus x, that's x, and then 3y plus 4y, that would be plus 7y. Okay, we are looking for the option that says 3x minus y and x plus 7y. That's option B. Option B, difference of two squares. So the difference of two squares is something you must familiarize yourself with. Take it as a challenge. If you did not spot this as a difference of two squares problem from the onset, then that means that there is an issue, right? So you need to go and practice difference of two squares. And I think on the platform we have questions on that. Okay, so that's question 37. Let's take on 38. 38 says, find the equation whose roots are 3 over 4 and minus 4. Whose roots are 3 over 4 and minus 4. We have a rule for, expressing an equation, by its roots, right? That rule is that x squared minus sum of roots, all right, x, then plus what? The product of roots is equal to 0. Okay, so once we can write this out, we are good. All right, or you could write it as x squared minus, so the sum of roots, the roots are alpha and beta, right? So alpha plus beta, x, then plus product of roots, alpha beta, is equal to 0. Okay, so what's alpha? The first root, we can say alpha is 3 out of 4, and then we can say beta is -4, right? So we just need the sum of the roots. So what's the sum? My sum is 3 over 4 plus minus 4, which is just 3 over 4, plus minus 4, rather, plus times minus is minus, right? I can say minus 4 over 1. LCM is 4, so we'd have 4 if 4 is 1, or 4 divided by 4 is 1, then times 3, that's 3, then minus 4 divided by 1 is 4, 4 times 4 is 16. So we'd have -11, -13 rather, my bad, -13 over 4. That's -13 over 4, so that's for the sum, right? So that means we can come here and write x squared minus -13 over 4 times x, then plus, all right, let's work on the product now. The product is alpha beta, so my product would be, the product is going to be alpha beta. That'll be 3 out of 4 times -4 over 1. All right, once cross out this, you would have -3. Okay, so plus minus 3 is equal to 0. Okay, so just expanding this negative sign here gives us x squared plus 13 over 4x minus 3 is equal to 0. So I need the space down here. Okay, we're nearly there. All that's left now is just to ensure that we don't have denominator, right? Because our standard form typically doesn't have denominators. We rather have a coefficient of x squared. So how do we deal with that? Well, typically we multiply by the LCM of all the denominators, all right? But we just have 4, so we multiply the entire thing by 4. All right, since you're multiplying both sides of the equation by 4, it's very valid because the influence on one side will cancel out the influence on the other side. All right, this will give me 4x squared plus 13x minus 12 is equal to 0. So 4x squared plus 13x minus 12 is equal to 0. I think that's option D, right? That's option D. So you must learn that whole sequence, right? X squared minus sum of roots x plus product of roots is equal to 0. You should learn the sequence, all right, and know it by heart. All right. So question 39 says, find the quadratic equation whose roots are negative half and 3. All right. Find the quadratic equation whose roots are negative half and 3. So they give us the roots, usually represented by alpha and beta, right? So alpha is negative half, and then beta is 3. Is that beta? Well, okay. So the formula for the standard quadratic equation that expressed by its roots is x squared minus the sum of roots by x, then plus your product of roots is equal to 0. All right. So we have x squared minus the sum of my roots would be let's just do one here, right? I like to do it separately. So let's add up negative 1 over 2 plus 3 over 1. Okay, my LCM is 2. 2 divided by 2 is 1, then times 1 is, well, that's minus 1, right? And plus 2 divided by 1 is 2, then times 3, that's 6. All right, so I have 5 over 2. All right, so minus 5 over 2x. Okay, then plus, what's the product of my roots? So let's do the product here. Product means to multiply. That will be negative half times 3. Negative 1 over 2 times 3 over 1, all right, which gives me negative 3 over 2. Okay, so x squared minus 5 over 2x plus minus 3 over 2 is equal to 0. Okay, so we can just expand this to say x squared minus 5 over 2x minus 3 over 2 is equal to 0, right? So just to make sure that we know that plus times minus is minus, right? So we're good. The only other thing now is that we do not like to have our standard form with denominators, right? We want to make sure that our standard forms are just whole numbers. So what we'll do is we'll multiply the whole thing by the LCM of the denominators. All right. So we just have 2. All right. So we just multiply the whole thing by 2. So 2 times x squared is 2x squared. All right. And 2 times minus 5 over 2 is minus 5. And then 2 times minus 3 over 2 is minus 3. That's equal to 0. All right. Good. So you must learn the sequence though, right? You must learn the sequence. X squared minus sum of roots x, then plus product of roots is equal to 0. Okay, that's for question 39. Let's take on question 40. Okay, so find the quadratic equation whose roots are c and negative c. Find the quadratic equation whose roots are c and negative c. Okay. So I have the standard formula is x squared minus sum of roots x, then plus product of roots, right? Is equal to 0. Okay. So my roots are alpha is c, and I can say beta is negative c. All right. So my sum would be c. My sum will be c minus c, right? So that will be, or c plus minus c, right? Which just gives you 0. All right. Then my product would be c times negative c, all right, which gives you negative c squared. Okay, so let's drop that in. So we have x squared minus sum of roots is 0, x, plus product of roots is minus c squared is equal to 0. So 0 times x is 0, right? So we'll just end up with x squared, and plus times minus is minus, so minus c squared is equal to 0. So we have x squared minus c squared is equal to 0. That's option A. That's option A.
All right, for the one says, find the roots of the equation 2x squared minus 3x minus 2 is equal to 0. Okay, so we can solve this. I mean, there are three methods for solving this, right? Squared, factoring, and quadratic formula. But because it can be factored, I would factor it. We have 2x squared minus 3x minus 2 is equal to 0. So we can write this as a product of two factors. We have b and then ac. My value for b here is negative 3, right? And then my value for AC is 2 times minus 2, which is minus 4. All right. So the two numbers that I can work with that would add up to give me B or multiply to give me AC is for R. I think that will be negative 4 and plus 1. All right. Negative 4 and plus 1. Because they will add up to give you negative 3 and then multiply to give you negative 4. We have 2x squared. We can now replace the value for B here with our lovely numbers here. Minus 4x plus x, all right, then minus 2 is equal to 0. What we have achieved is that we have set up the equation such that the product of the term in the middle is the two terms in the middle is same as the product of the two terms at the end. All right, so once you have this, you're sure you can go on to factorize nicely. I'll break this up into two, and from the first group, I can factor out 2x. I would have x minus 2. From the second group, I can factor out just plus 1, right? That 1 is the only thing that is common to both of them. And I'll have x minus 2 is equal to 0. So since we have x minus 2 in both, both terms as we have it here, then what I will do is I'll factor out x minus 2 from the whole thing, right? I'll factor out x minus 2 from the whole thing. I'll have x minus 2 such that from the first group I'll have 2x, and from the second group I'll have 1 from the second term, right? So I've dragged out x minus 2 from the whole thing, and I have this. Good. So we have two things multiplying themselves to give you 0, so which means that one of them must be 0, right? So it's either x minus 2 is equal to 0 or 2x plus 1 is equal to 0. So we have x is equal to 2 or 2x is equal to negative 1. So x is equal to negative 1 over 2. All right, so we have x as negative 1 over 2 or x as 2. That would be option A. All right, x as negative 1 over 2 or x as 2. All right, next one says, find the smaller value of x that satisfies the relationship. Right, so we need to solve this and then solve to get the solution. So I have x squared plus 7x plus 10 is equal to 0. All right, so we need to rewrite this to factor. I'm working with factorization. So yeah, my value for b is 7. My value of a times c, that's a is 1, right? Because that's the coefficient we have behind x squared. So 1 times 10 is 10. All right, so we need to find two numbers that will add up to give us 7 and multiply to give us 10, and that has to be 5 and 2. All right. So using these numbers, we can replace, the b value here. So we have x squared plus 5x plus 2x plus 10 is equal to 0, right? Such that we've rewritten the equation such that the product of the terms in the middle, 5x and 2x, your product is the same as the product of the term at the ends, right? X squared and 10. So once you have that set up, all right, such that the product of these two terms is same as the product of these two terms, then you're sure that you can factor by grouping, all right? So let's group, we'll split in two. What can I find in x squared plus 5x that is common? I can factor out x, right? So I have x plus 5. And here I can factor out plus 2, and I'll also have x plus 5. All right, so generally we just have x plus 5, factoring out x plus 5 from the whole thing. From the first bit here, I'll have x, and then from here, I have plus 2 is equal to 0. So it's either x plus 5 is equal to 0 or x plus 2 is equal to 0. So in this case, x would equal negative 5. In this case, x would equal negative 2. The question is, which is the smaller value? Negative 5. Negative 5 is smaller than negative 2, right? Negative 5 is smaller than negative. All right. So find the truth set of the equation that
basically we're just saying, okay, what values, make this statement true, right? So just need to solve for this for the solution. Okay, so let me come and do this over here. We have x squared minus 3 bracket 2x plus 9 is equal to 0. So I can expand this and to get x squared minus 6x minus 27 equal to 0. I'll solve this by factoring my value for b and then ac, right? Right back. All right, b is negative 6 and ac, so a is 1, right? The coefficient of x squared is 1. So 1 times minus 27 is minus 27. Need two values that will multiply to get minus 7 and add to get negative 6. Those two numbers, we have to work with 9 and 3. All right, so that's minus 9 and plus 3, right? Because minus 9 plus 3 gives us negative 6, but minus 9 times 3 gives us minus 27. So this equation is can be rewritten as, separating this negative 6 would have x squared minus 9x plus 3x minus 27 is equal to 0. All right, so written that way, such that now we can split this. In the first group here, I can factor out x. So I'll have x bracket x minus 9. Good. In the second group here, I can factor out 3 plus 3 bracket x minus 9. Right, so we've grouped them. But we can do something further, right? Because since we have x minus 9 here and x minus 9 here, I can go on to factor out x minus 9. And then from the first group, I will just have x. From the second group, I'll just have 3. Okay, we are there now, right? Where we have two numbers multiplying themselves to give you 0. If two numbers will multiply themselves to give you 0, then one of them must be 0. All right, so either x minus 9 is equal to 0 or what? Well, x plus 3 is equal to 0. One of these two guys must be 0 if they would multiply to give 0. That means that one solution to x is 9 when you solve that, or one solution to x is negative 3. All right, so our truth set would be the set that contains x as 9, and x as negative 3. 9 and negative 3, that's option B. 9 and negative 3. Okay. 44 says, find the value of x in the equation. So we have 3x squared minus 8x minus 3 is equal to 0. Okay, so I'll solve using factorization, right? B and then AC, right? My value for B in this setup is negative 8, right? That's the, because we have A, B, C. My value for B is negative 8. And my value for A times C, 8 times C would be 3 times negative 3. That's negative 9. All right, 8 times C would be 3 times negative 3. All right, let me just take those dots. Okay, so 3 times negative 3 is negative 9. All right, so what two numbers will I add to give negative 8 but multiply to give negative 9? Those numbers have to be, well, we have to use 9 and 1. So I think it's going to be negative 9 and positive 1, right? So they can add up to give negative 8. Good. So here's what we'll do. We'll rewrite the statement and then rewrite negative 8x using our two lovely numbers. So we'll have 3x squared, all right, minus 9x plus 1x, all right, then minus 3 is equal to 0. Okay, from the first group here, I can factor out 3x, so 3x bracket x minus 3. And from the second group, I can factor out, just drag out 1, right? Factor out 1, I'll have x minus 3 also. From where we are, we have x minus 3 common to both groups, so I can factor out x minus 3. And then if I factor out x minus 3 from this, I'll be left with just 3x. Factor out x minus 3 from these, I'll be left with just plus 1. All right, so end up with x minus 3 times 3x plus 1 gives you 0. Okay, good. But then, if two numbers multiply themselves to give you 0, then it implies that one of them must be 0, right? So it's either x minus 3 is equal to 0, right? That's something that could be true. Or what? 3x plus 1 is equal to 0. If x minus 3 is equal to 0, that means that x is 3. Or if 3x plus 1 is equal to 0, that means that 3x is equal to negative 1. And if I divide both sides by 3, x is equal to negative 1 over 3, right? So x is equal to 3 or x is equal to negative 1 over 3. That's option D. Okay, that's 44. 45 says, find the value of m, which makes x squared plus 8x, x squared plus 8x plus m a perfect square. All right, so our rule for setting up a perfect square is that, well, you need to ensure that a is equal to 1, right? A is equal to 1, and then your value for c must be equal to b over 2 all squared. So we have x squared plus 8x plus m. So a is 1, that checks. A is 1. And then let's now check for c. C is b over 2 all squared. That was 8 over 2, which is 4, and all squared. That means that the value of c, which is m in this case, must be equal to 8 over 2 all squared, which is 4 squared, which is 16, right? So m must be 16. So this is a perfect square. All right, it's now a perfect square because the value for c, or after you've ensured that a is 1, then the value for c is b over 2 all squared. All right, that's it for number 45. All right, 46 says, sorry, I didn't pick an answer for 45, but 5 is. 46 says, find the values of k in the equation. Okay, so we can solve this here, right? Find the values of k in the equation. We have 6k squared is equal to 5k plus 6. 6k squared is equal to 5k plus 6. Okay, so I'll set it up in standard form, right? So I'll go 6k squared minus 5k plus 6 is equal to 0. All right, and as always, I'll go with factorization. I would always go with factorization. The reason why is because it had a lot of other applications, right? So just so that, okay, we can master the skill. But you must be skilled with quadratic formula and completing the squares also, right? All right, so the value for b here, I like to write b as c. That's my hack. The value for b here is minus 5. And the value for ac, so that's 6 times 6 is 36. All right, 6 times 6 is 36. So we need to find numbers that add up to, oh my bad, sorry, this should, right? Because this 6 here also came over, right? So everything here came over, 0 on the other side. Let me write this properly. Okay, so minus 36. So we need to find two numbers that will multiply to give us 5 and then add up to give us, multiply to give us minus 36 rather. So multiply to give us AC and then add to give us B, minus 5. All right, so in this case, the numbers have to be, I think we should go with 9 and 4, all right? Because 9 times 4 is 36, and then when you subtract them, so that means we have to have minus 9. Okay, so good. So checking that, minus 9 times 4 gives minus 36, minus 9 plus 4 gives minus 5, and minus 5, good. So we can use, these lovely numbers that we have here now to replace our values for B, right? And we'll be good to go. So we have 6k squared minus 9k plus 4k minus 6 is equal to 0. So we used, minus 9 and 4, my values for these two values to replace the value for B. All right, so what next now is grouping, right? We're ready to group. 6k squared minus 9k, what's common there is we can factor out 3k, all right? We can factor out 3k and then I'll be left with 2k minus 3. From this, I can factor out plus 2 and I'll be left with 2k minus 3 also. Brilliant, good. So I have the same thing in the brackets, which means like that's a good sign, right? We can factor out what's in the bracket, so I'll drag that out. I would have 2k minus 3, all right? And then from the first group, if I factor out 2k minus 3 from the first group, I'll be left with 3k. If I factor out 2k minus 3 from the next group, I'll be left with plus 2, all right? So this is where we are. 2k minus 3 times 3k plus 2 is equal to 0. Finally, if two numbers multiply themselves to give you 0, right, that means one of them must be 0. Let me write this here. Sorry, we have 2k minus 3 and 3k plus 2, all right, is equal to 0. So If they multiply themselves to give you 0, one of them must be 0. All right. So if 2k minus 3 is equal to 0, or 3k plus 2 is equal to 0, right? In the first instance, that means 2k has to equal 3, all right? And then k has to equal positive 3 over 2. Second instance, we have 3k has to equal negative 2, and then k has to equal negative 2 over 3. So we should be looking for the solution that has the set 3 over 2 and negative 3 over 2, and negative 2 over 3 rather. Negative 2 over 3 and 3 over 2, that's option C. Okay, again, I mean, factorization is cool, right? But you must also know your other methods, right? You must also know your other methods. Okay, good. So that's for 46. Let's go to 47. 47 says, find the values of x for which the expression is undefined. Okay, so undefined happens, or a function is no longer defined when the denominator is 0. That's one of the instances when the function would not be defined. All right, when the denominator is 0, because you can't divide by 0. Divide by 0, just your quotient will just shoot all the way up to infinity, right, and never quite arriving. So if you graph it, you won't find that point. That point will be missing. All right, so yeah, so it's undefined at that point, right? So whatever makes denominator 0 would make the whole system undefined. Okay, so that means that we need to find where x squared plus 4x minus 5 is equal to 0. That's when our function will not be defined. Okay, I would solve using factorization. B and then AC. What's my value for B? My value for B is 4. And then my value for AC is 1 times minus 5, right? So that's minus 5. Okay, good. So 4 and minus 5. I need to find two numbers that I can use to replace this plus 4, right? But so I need to add to 4 but multiply to give negative 5. I think the numbers have to be 5 and negative 1. So check that. Add to give 4, multiply to give minus 5. Brilliant. So we write this as x squared, and in place of 4x, we'll have 5x, and then minus x minus 5 is equal to 0. Okay. So at this point now, we're sure our grouping can happen unhindered, right? We're sure our grouping can happen unhindered. I'll split this up here. I can drag out x, right? X is common to both of them, so I'll factor out x from the first two. So x bracket x plus 5, and I can factor out negative 1, all right? So whenever I have a leading coefficient that is negative, right, in either of the groups, you always factor out the negative 1, just to make sure that, okay, there's no irregularity, right? So I always factor out negative 1. That just gives me a standard to further ensure that I don't have the two brackets, having separate values in them, different values in them rather. Okay, so factor out negative 1, and here I'll have x plus 5, right? So I can factor out x plus 5 from both of them, obviously, right? So because x plus 5 is here, x plus 5 is here. So this would be x plus 5 factored out. And then what's left? From the first group, I'll have x left. From the second group, I'll have minus 1. All right? So I end up with, I'm moving this over here, sorry. Good. So I end up with x plus 5 times x minus 1 is equal to 0. If the product of these two values is 0, it means that one of them must be 0, right? So it's either x plus 5 is equal to 0 or x minus 1 is equal to 0. If x plus 5 is equal to 0, that means that x is equal to negative 5. If x minus 1 is equal to 0, it means that x is equal to 1. So we are looking at 1 or negative 5, right? 1 or negative 5. That's option B, right? 1 or negative 5. Okay, good job. So 48, we have a similar question. Find the values for x or which is not defined. So I think there's an issue with the text, right? So it should be find the values of x for which, the function or something, the expression is not defined. All right. Anyway, the function would not be defined when your denominator is 0. Dividing by 0 We usually say it's impossible, yeah, which does make sense. But the actual, or a better way to describe it is that when you divide by zero, your quotient just spikes up to infinity, never quite arriving at infinity, but just spikes up to infinity, such that if you graph it, all right, at that point there, that value would be, would be non-existent. Okay, so it's important that our denominator doesn't become zero. So the values of x for which the expression would not be defined, right? The values for x for which the expression would not be defined is or are the value for x that the denominator is zero. Okay. So basically, they're just asking us to solve for where this guy here, right, is equal to zero. So we have, let me do here. We have 2x squared minus 13x plus 15 is equal to 0. We're asked to solve, okay, what's the solution to this? Those values for x are what's going to constitute, an undefined position for that, right? Okay, good. Okay, so write b and ac, right? That's my hack. The value for b is negative 13. The value for a times c is positive 30. All right. Now we need to think of two numbers that will add up to give us b and multiply to give us 30. Those two numbers have to be, well, factors of 15 and 2, but I believe minus 15 and plus 2. All right, so let's try that. Minus 15 plus 2 is minus 13, and then minus 15 times 2 is not positive 30. No, I'm wrong. So it's not minus 15 and 2, right? It's not minus 15 and 2. My bad. It's let's try again. Okay, let's try 10 and 3, right? So 10 and 3. Okay, so in fact, minus 10 and minus 3, brilliant. So minus 10 and minus 3. Okay, good. So we have the numbers now, right? Because if you add them up, you get negative 13. If you multiply them, you get positive 30. Okay, we use these two numbers to replace the negative 13, right? Value for b, and then we should be able to group easily. So we have 2x squared minus 10x. So we're replacing this 13x, negative 13x, right? Then minus 3x, then plus 15 is equal to 0. Progress. So let me split this out. Okay, from here I can factor out 2x, right? I can factor out 2x from the first group. So I'll have 2x bracket x minus 5. And then from the second group, I can factor out, looking at both of them, I can factor out negative 3, right? So I have it as a rule to always factor out the negative sign. If I find a negative sign, a negative sign, yes, as a leading coefficient of any of these, right? It saves you the chance of having your brackets, the values you have in the brackets, your binomials different. So this would be x minus 5. So I always factor out this negative sign if I find it, if I find it there, is equal to 0. Okay, good. So now we have x minus 5 in both. Brilliant. So I can factor out x minus 5. And so if I factor out x minus 5 from here, I'll have 2x. I factor out the x minus 5 from here, I'll have minus 3 is equal to 0. So I have x minus 5, right? Then times 2x minus 3 is equal to 0. Okay? So it's either, if they multiply to give you 0, one of them must be 0, right? So it's either x minus 5 is equal to 0, or what? 2x minus 3 is equal to 0. If x minus 5 is equal to 0, that means x would equal 5. Or if this is the case, that means 2x would equal 3. Right, when I move 3 over, right? And then dividing both sides by 2 leaves x as what? 3 over 2. All right, so x is 5 or x is 3 over 2. That's option D. All right. 49 says, find the values of y for which the expression is undefined. Okay, so we want to find the values for y for which the expression is undefined. All right. So one of the ways your function could become undefined is when your denominator is 0, right? So dividing by 0 produces an undefined function, right? It's not the only It's not the only reality, right? But there are other things that can make a function undefined, like maybe trying to take square root of a negative number, or logarithm to the base of a negative number, or even the logarithm of a negative number itself, I believe, right? Yeah. So there are a number of things, but for this, it's just your denominator can be zero. Because if you try to divide by zero, even though we say it's impossible, you usually get math error. But a better way to probably describe it is that when you divide by zero, your quotient just shoots up to infinity, right? So it never quite arrives, it just keeps on going. So if you needed that value, you will never arrive at one. If you even graph it, right, you'll find out that you can't find a place where that point will just be empty, right? The graph will not exist at that point. So that's the thing there. So when they say where is a rational function, right, a function that's like a fraction undefined, then your point of contact is, wait, what makes the denominator zero? All right, good. So we're going to take this now and say, basically, we don't care about the numerator. We just need to know where 5y squared, so let me do this here, y squared plus 4y minus 21 is equal to 0, right? So y squared plus 4y minus 21 is equal to 0. Where whatever values of y produces this, the function is undefined at that point. Okay, so I'll work with factorization. My value for b is 4, and then my value for ac. So I like to write back, right? BAC, and b is 4, and then ac is 1 times minus 21, which gives me minus 21. Good. The next task now is to think of two numbers that will multiply themselves, to give ac but add to give you b. Multiply to give ac but add to give you b. Those two numbers will be 7 and minus 3, right? So 7 and minus 3. Okay, so we can use those two numbers now to replace the value for b here, which is 4y. All right, so that we can now solve by, we can now factor by grouping, right? So y squared plus 7y minus 3y minus 21 is equal to 0. Okay, good. So you can factor by grouping if the product the product of the two values at the end, right, is same as the product of the two values in the middle, right? That gives the license to factor by grouping. Okay, so and you can test this. So the whole idea of doing BAC neatly here and then trying to figure out the two numbers that should replace the value for B is so that we can establish a scenario where the product of the two numbers in the middle is the same as the product of the two numbers at the end. All right, good. So let's begin. Let's group. From the first group here, we can factor out y, right? So we have y bracket y plus 7. And then for the second group here, the one on the other side, we can factor out negative 3, all right? And then we'd also have y plus 7. But so I always factor out, if I have a leading coefficient that has a negative sign, I always factor it out, okay? Just to ensure that what I have in the brackets are the same, all right? So it's just a rule that I use. Okay, good. So anyway, now we are where we would like to be. We have the same values in the brackets. So that means we can factor out that binomial, right? We can factor out y plus 7. Factor out y plus 7. From the first group here, I'll be left with just y. From the second group here, I'll be left with just minus 3. So y plus 7 times y minus 3 is equal to 0. So quick one. If the two values multiply to give you 0, one of them must be 0. So we can proceed to say, right, that y plus 7 is equal to 0, or y minus 3 is equal to 0, because there's no way two values can multiply themselves to give you 0 without one of them, or at least one of them being 0. All right, so this means that y would be negative 7 or y would be positive 3. So these are the two solutions, possible solutions that we have. Negative 7 or positive 3. That is A. Okay, that's for 49. And then number 50 says, for what value of x is the expression not defined? Okay, good. So for what value of x is the expression not defined? Good. So let's look at that. Now, for your irrational expression to not be defined, it means that the denominator is not 0, is 0 rather, right? So you can't divide by 0. If you divide by 0, you get an undefined answer. If you try it on your calculator, you probably see maybe error or math error or something, right? So your denominator is not allowed to be 0 in any rational expression. If you even graph it, if you graph it, you would find out that when you get to that point, right, or that that value for x, whatever makes the denominator 0, you find out that you can't find the point, right? Because when you divide by 0, what happens is that the quotient, the answer to that expression, it just shoots to infinity without end. Okay, so it could be positive or negative infinity, right? But it just shoots. So you will just find out that your function, it cannot be found. That's why we say it's not defined, because we can't find it on the graph. Okay, good. Anyway, so simple as ABC, right? We just need to find where the denominator is 0. We need to find out where x minus 5 is 0. That's where to be undefined. So the solution is x is equal to 5. All right, that's option B. That's option B. Good. All right, question 51 says, for what value of y is the expression not defined? Okay, so my expression is not defined. When you have a rational expression like this, right, it will not be defined when your denominator is 0. Right, so because you can't divide by 0, you could try it on your calculator. You either see maybe math error or yeah, just something like that, right? And the idea is that if you try to divide, just think about it. If you divide a number by 0, you can use limits. Try dividing by values as they approach 0. You find out that your quotient, right, the answer to your division problem begins to skyrocket towards infinity. Right, so you can't pick it, because when something is going towards infinity, it's a journey, it never quite gets there, right? If you even graph it, you find out that at the point where the denominator is supposed to be 0, right, at those values or that value, you find out that that point should just be missing. So there's no definition for it, right? You can't even find it on the graph. Okay. Anyway, so long and short of it is that when you ask for something like this, where your function is not defined, you are looking at where your denominator is 0. So that means you're working with where y squared minus 3y minus 10 is equal to 0. Okay, we can solve this by factoring. So we need to replace the values in the middle such that the product of the values in the middle is same as the values at the end, right? So we need to replace 3y with two numbers that their product is the same thing as the value of, their product is the same thing as y squared times minus 10. Anyway, we have a neat trick for that, right? We just write out back b and then ac, and then so our b here is minus 3, a times c here is 1 times minus 10, which is minus 10. And now we need to think of two numbers that will add up to give b, right, to give minus 3, but multiply to give minus 10. Working with factors of minus 10, those two numbers have to be negative 5 and positive 2, right? So we can use these numbers to replace, the b, right? So this will become y squared minus 5y plus 2y minus 10 is equal to 0, right? So now we have it such that the product of the terms in the middle will be the same as the product of the terms at the end. That means we can go on to factorize, split this up in 2. From this first bit here, I can factor out y, right? This will be y bracket y minus 5. And then from the second bit here, I can factor out plus 2. 2 bracket y minus 5 is equal to 0. All right. Since I have y minus 5 and y minus 5, I can factor out y minus 5, right? So this becomes y minus 5. From the first group here, I will have just y left. From the second group here, I'll have plus 2. All right, is equal to 0. So if these two values multiply to give you 0, it implies that one of them must be 0, right? The only way that you would have a product of two numbers give you 0 is if one of those numbers, one of those factors themselves, is actually 0. So that means that either y minus 5 is equal to 0 or y plus 2 is equal to 0. If y minus 5 is equal to 0, it follows that y must be 5. If y plus 2 is equal to 0, it follows that y must be negative 2. All right. So these are our two solutions, 5 and negative 2. So the correct option is option A. Right. So at y is equal to 5, your function will be undefined. At y is equal to 5, your function will be undefined. Okay, 52 says, For what value of x, let me take that out. For what value of x is the expression 2x minus 1 divided by x plus 3 not defined? For what value of x is this not defined? Okay, so your function will not be defined when your denominator is 0, right? You can't divide by 0, try it on your calculator, it shows math error or something, some error message, right? And even if you try it, you'll find out that as you approach 0, right, as you try to divide by values that approach 0, your quotient will just be, shooting up to either positive infinity or negative infinity, right? So it's not something you can capture, right? You can't define it by a particular location. And even if you graph it, so same thing, right? You just find your graph just shooting away, to infinity as you approach that value usually. So to solve this is very simple, right? It's not defined when this guy here is equal to 0. That's the problem. Okay, so we are just solving for when x plus 3 is equal to 0, all right? And that is when x is equal to negative 3. So the correct option is option B. Correct option is option B. Right, that's for question 52. For question 53 says, for what value of x is the expression not defined? For what value of x is the expression not defined? All right, so the expression is not defined when your denominator is 0, right, for rational functions. Because you can't divide by 0, your denominator cannot be 0. I mean, you could try it on your calculator, try dividing any value by 0. You maybe get an error message or, something like that. Yeah. So let's say this. We're looking at where this is, the issue is that x squared, that's the denominator, minus 2x minus 3 cannot be 0, right? Wherever this is 0, it's where we have that issue. Okay, so we can solve this, factorization just implies we need to group, right? So that means we need to separate the value in the middle into two values that will add up, that would multiply themselves to give you, the same product as the starting value and the end value, right? I have a neat trick. I just write back b and then ac, right? What's the value for b? B is negative 2. What's the value of a times c? That's negative 3, all right? We need to find out what two numbers would add to produce b, but then multiply to produce a times c. Okay, so those two numbers would have to be, I think, negative 3 and plus 1. All right, negative 3 and plus 1 would do that for us. Yes, correct. But so we can use this to replace the value in the middle. We'll have x squared minus 3x plus x, that's 1x, right? Plus 1x, then minus 3 is equal to 0. And you can test it. You'll find out that the product of the numbers in the middle, the two numbers in the middle, is same as the product of the two terms in the middle, rather, is same as the product of the two terms at the end, all right? So that means we're going to factor by grouping, split this up down the middle. X squared minus 3x, I can factor out x, right? So if I drag out x, I'll have x bracket x minus 3. And from here, I can just factor out plus 1, all right? Plus 1 is the only thing that can divide both of them, right? So x minus 3. All right, so since I have the same two things, the same binomial in the bracket, right? So I can factor out the binomial. I can factor out x minus 3 from the entire thing, right? So I'll factor out x minus 3. And then from the first group here, I'll be left with x. And the second group here, I'll be left with plus 1. All right, is equal to 0. Finally, if these two values, sorry, let me finish this up here. If these two values multiply themselves to give you 0, right? If we have, so let me write that again, x minus 3, x plus 1 is equal to 0. If they multiply each other to give you 0, then it implies that one of them must be 0, right? So it's either x minus 3 is equal to 0 or x plus 1 is equal to 0. Okay, so for this, it implies that x is equal to 3. And for this, it implies that x is equal to negative 1. So we are looking at x is equal to 3 and x is equal to negative 1. That's option C, right? Negative 1, 3. Sorry. Okay, that's it for question 53. Let's take on question 54. Okay, good. It says, for what values of x is the expression, all of that not defined, all right? For what values of x is the expression not defined? Very good. So your function, a rational function, right? It would not be defined when your denominator is 0. All right. So a rational function will not be defined when your denominator is 0. So anything that makes what you have at the bottom be 0, because we can't divide by 0. All right. So think about it. If I you can try to check calculator, right? If I do that, anything divided by 0, I'll get an error message, maybe math error or something. All right. And if you even tried, by using limit, just try to divide by values as they approach 0, you find out that the answer you would get, your quotient, would keep on shooting towards either positive infinity or negative infinity. So, it just doesn't work. All right. So find out the values of x for which it is undefined. We just need to find out where this guy is equal to 0, right? That's the problem. Or those values are the problem. Okay, so we have 4x squared plus 9x minus 9 is equal to 0. I can solve this by factoring. Let's try. I just need to split this, the value in the middle. I need to get two values that their product would be the same as the two values at the end, right? There's a neat trick for that. I just use b and then ac. Okay, just write back. Such that the two values I'll be looking for, so my b is 9, hold on, and then ac is minus 36, right? That's 4 times minus 9, that's minus 36. So the two values I'll be looking for will be values that will add up to give 9 and then multiply to give negative 36. Add up to give 9, multiply to give negative 36. Those two values have to be, I think that'll be 12 and negative 3, right? Yeah, so these are the factors of 36 that would do it. Add up to give 9, multiply to give negative 36. Good. So I can rewrite this as 4x squared, all right, then plus 12x minus 3x minus 9 is equal to 0. So we've achieved two things. The first thing we've achieved is that the product of the values in the middle, both of them, is the same as the product of the values at the end, right? So the product of these numbers here is same as the product of these numbers here, right? So that's how you know you can factor, and that's what we're trying to achieve. And also, we did not change the equation in any way, because 12x minus 3x gives you back the 9x that was there originally. Okay, so let's move. We can factor out 4x from this. I can drag out 4x. If I drag out 4x here, I'll be left with x plus 3. Here, I can factor out negative 3, right? I can factor out negative 3 from here. I'll also be left with x 3. All right. So I always factor out in the a negative from the first time if I find it. And it just ensures that I wouldn't have the issue of maybe I've done everything properly, but the values in my brackets are not the same. It just sets a standard for me. Okay, I can factor out now because x plus 3 is the same, right, in both terms. So I can factor out x plus 3 itself. So x plus 3 out. From the first group, I'll have 4x left. From the second group, I will have minus 3 is equal to 0. All right, so let's finish this up here. We have x plus 3, all right, and 4x minus 3 is equal to 0. If these two values multiply themselves to give you 0, it implies that one of them must be 0, right? So it's either x plus 3 is equal to 0 or 4x minus 3 is equal to 0. If x plus 3 is equal to 0, it means that x is equal to minus 3. If 4x plus 3 is equal to 0, it means that 4x is equal to 3. And then dividing both sides by 4, right, means that x is equal to 3 over 4. Positive 3 over 4. So our solution is that x can be positive 3 over 4 or x can be minus 3. That's option A. All right, that's option A. Okay, so question 55. For what values of y is what we have there not defined? Okay, so your function will not be defined when your denominator is 0. All right, so anything that makes your denominator be 0 would also at the same time ensure that your function is not defined, a rational function, right? And you can try it on your calculator. You can't divide by 0. If you even try to use limits to think about it, for those of you that do further math, if you try to plug in values very close to 0, right, like 0.000001, or 0.0000, stuff like that, right? You find out that the closer you get to 0, the more your values, just your quotient just shoots towards infinity. All right. So you can't, I mean, if you're going towards infinity, you can't define that position, right? What value is infinity? That's one. And if you even try to graph it too, the same thing plays out. Your value just shoots up either to a positive infinity or negative infinity, right? Depending. So yeah, so basically the long and short of it is that the issue we have is that our denominator cannot be 0, right? So it's going to be undefined or not defined when this guy is 0. Let's solve what value makes that 0, what values of y makes y squared minus y minus 6 equals 0. What values make that equal 0? Okay, good. We can solve this by factorization. That means we just need to rewrite the middle term here. All right. There's a neat trick I use. I write BAC back. My B is -1, and then my A times C, that's 1 times minus 6 is minus 6. All right. So now I just need to think of two numbers that will add up to give me B, but multiply to give me A times C. Those two numbers will be minus 3 and plus 2. Minus 3 and plus 2. So such that this becomes y squared minus 3y plus 2y minus 6 is equal to 0. Okay, so from these I can factor out, I believe I can factor out y, right? So I'll have y bracket y minus 3. From this I can factor out plus 2, then bracket y minus 3 is equal to 0. All right. Since I have the same thing in the brackets, I can factor out y minus 3 itself. So I'll have y minus 3. And then from the first group here, I'll be left with just y. And from the second group here, I'll be left with plus 2. All right. Yes, from the second group, I'll be left with plus 2 is equal to 0. All right. So we have y minus 3 and multiplying y plus 2 is equal to 0. This means that either y minus 3 is equal to 0 or y plus 2 is equal to 0. Okay? If the first is the case, we'll have y as 3. If the second is the case, we'll have y as negative 2. Right? So the answer is 3 or negative 2. That's option C. All right, 3 or negative 2. That's option. All right, question 56 says, for what value of y is the expression undefined? So your expression will not be defined when the value when your denominator is 0, right? So basically you can't divide by 0. You could try it on your calculator or try graphing the function. You find out that okay, so if you try it on your calculator, you just get math error. But if you try to graph this maybe on Desmos or something, you find out that as you approach that value, right, you see your function just either shoots towards infinity or something like that, infinity or negative infinity, it shall be missing. All right. So yeah, your function is shall undefined where this denominator is 0. All right. So the issue is, let's solve for where y squared, what makes the denominator 0. That's what makes it undefined. Okay, we can solve this by factoring. So to factor by grouping, you need to rewrite the middle term such that the product of the middle terms, the two middle terms you would have would be the same as the product of the two terms at the end, right? So we have a nice trick for that. Just say b and then ac, right back. Your b here is negative 3, all right? That's the coefficient in the middle. And your a times c, that's 1 times minus 10, which is minus 10. And we just need to think of two values that would add up to give us b and multiply to give us a times c. Factors of minus 10, so that will have to be minus 5 and plus 2, right? Minus 5 and plus 2, such that this becomes y squared minus 5y plus 2y minus 10 is equal to 0. All right, so I used the values I just, got to replace the value for b, such that the product would be the same. The product of the two values in the middle will be the same as the product of the two values at the end, and at the same time, it's still equal to the value of b that was there before if I sum them up. Okay, anyway, now we're sure we can factor comfortably, right? To split this up in two, from the first group here, I can factor out y. I'll have y bracket y minus 5. Okay, and then from the second group, I can factor out plus 2 minus y bracket y minus 5. All right, so I'll pick this up and drop it here and continue here. So I have y bracket y minus 5 and then plus 2 bracket y minus 5 is equal to 0, because that's where I was, right? Okay, so that means that from this I can drag out y minus 5, because y minus 5 is common to both of them, right? So I'll say y minus 5, factoring it out. From the first group here, I'll be left with just y. From the second group here, I'll be left with plus 2 is equal to 0. Okay, so it's either y minus 5 is equal to 0, all right, or what? Y plus 2 is equal to 0. And we take this position because if two values multiply themselves to give you 0, then at least one of them must be 0. So if y minus 5 is equal to 0, that gives y a value of 5. If y plus 2 is equal to 0, that says y must be negative 2. Right, y must be negative 2. So the answer is 5 or negative 2. So take 5, B. Okay, so that's it for question 56. Let's move on to question 57. Question 57. Form the equation whose roots are x is equal to half and x is equal to negative 2 over 3. Okay, so the general form of your quadratic equation, right, that has been expressed, with the roots is x squared minus sum of roots, close bracket x, plus product of roots is equal to 0. All right, so x squared minus sum of roots x plus product of roots is equal to 0. So we'll have what are my roots? My roots are half, and the other root beta is negative 2 over 3, right? So let's figure out, it's as simple as figuring out the sum or calculating the sum, then calculating the product of the roots, right? And then now using them to plug them into this equation and we're good. Okay, so what's my sum? My sum is 1 over 2 plus minus 2 over 3, right? So plus minus 2 over 3, which is just 1 over 2 minus 2 over 3. All right, my LCM is 6. 6 divided by 2 is 3. 3 times 1 is 3. Minus 6 divided by 3 is 2. Then times 2 is 4. Right? So that's going to be negative 1 over 6. All right, so that's my sum. Then my product is 1 over 2 times negative 2 over 3. All right, that's my product, right? So I'll have 2 here, 1, 2 here, 1. So I'll have 1 times negative 1 is minus 1, right? Because, yeah, so that's minus 1 over 1 times 3 is 3. All right, so minus 1 over 3. So my sum and my product. So I can come here and rewrite this. I would have x squared. Sorry, let me pick black. X squared minus my sum of roots is negative 1 over 6x. Then my product of roots is positive 1 over 3 or negative 1 over 3 equal to 0. Okay, good. So simplifies to x squared plus minus times minus is plus, right? 1 over 6, then minus 1 over 6x, then minus 1 over 3 is equal to 0. Okay, because plus times minus here is minus. This is minus, right? So plus times minus is minus. Okay, good. So the final thing now is that we generally do not like having denominators in the standard form of an equation. So we want to multiply everything by the LCM of denominators, right? So I'll multiply the whole thing by the LCM of denominators. I'm multiplying by 6, right? So I'll just take 6 to multiply the whole thing. So this will become 6x squared. and then 6 over 6 times x, that's just, so plus 1x, right? Plus 1x. And then 6 times negative 1 over 3 will give me minus 2 is equal to 0. All right, so this is the final answer. Okay, this is the final answer. So it's very simple, and you probably need to be very careful because of the signs, right? Use your brackets properly and all of that. But it's actually a very simple idea. Once you remember this relationship here, then it's just as simple as doing the basic operation, your basic operations and plugging in. All right, so the correct option is option 6x squared plus x minus 2. That's option C. All right, as I have it here. Okay, question 58. Given that, this is that, what's the value of m? Given that 2x minus 1 times x plus 5 gives you that, what's the value of m? Okay, so basically, we can just expand this and then see what m is, right? See what m is after expansion. So I have 2x minus 1 multiplying x plus 5. All right, so I'm just going to do 2x times x and then 2x times 5, right? Then I'll do minus 1 times x and minus 1 times, okay? So let's do it one by one, okay? So 2x times x gives me 2x squared. Then 2x times 5 gives me plus 10x. And then minus 1 times x gives me minus x, minus 1x. And then minus 1 times 5 gives me minus 5. All right, gives me minus 5. Yes. So all that is left is to collect like terms. I would have 2x squared plus 9x minus 5. So I have 2x squared plus 9x minus 5. So by comparison, right, plus 9 is equal to minus m. All right, so I mean, if I need m, I can divide both sides by negative 1, right? So I'll get m as what? Negative 9. Okay, so m is negative 9. That's option D. Okay. Because again, so this could be confusing because someone might just solve this from here and say, oh, the answer is positive 9, but it's not positive 9 because the expression here is negative m, right? So negative m is equal to plus 9, so that means that it has to be, m itself has to be minus 9. Okay, that's for 58. Let's go 59 now. So we are told that given that 2x plus 7 is a factor of that, find the other factor. So there are two ways to do this, right? You could either use long division, but I don't think long division is covered in your quadratic equation curriculum for mathematics. It's only covered, I think, in further mathematics under polynomials. So, but we can, I mean, it's a quadratic, so we don't really have to do long division. We can just factor this guy here, right? And then we'll see this as one of the factors and we can pick out the other factor. All right. Another thing, I think the answer is B also, right? Because, well, if you think about it, when you expand, you're likely going to do this times this to get the last term, right? Which is going to be, minus 14. And that's the only option that has negative 2 as a term. So again, there are ways around it, right? So if it's an exam, since it's a multiple choice question, you might not have had to solve it. But yes, let's just factor and see. So we have 2x squared plus 3x minus 14, and then we want to factorize this. So write out my B and AC. This would allow us to split up, the 3 in the middle, right? So that we can group properly. So, but what is B? B is 3. And then A times C, that's 2 times minus 14, that's minus 28. All right. So the two values that would multiply to give you minus 28 and add to give you 3 would be 7 and minus 4, right? 7 and minus 4. So I can rewrite this, this whole thing here and replace the middle value with those. So I'll have 2x squared plus 7x. Let me just move this and write properly. Sorry. Okay. So now I have 2x squared plus 7x minus 4x minus 14 is equal to 0. All right, so 2x squared plus 7x minus 4x minus 14 is equal to 0. I can factor out x from the right here. I would have x plus 7. I can factor out minus 2 from here, and I'll get, sorry, 2x plus 7. I'll factor out minus 2 from here, and I'll get 2x plus 7, right? Yeah, sorry, I was a bit hung up because so x and 2x squared is 2x, right? So yeah, so I can factor out 2x plus 7, so 2x plus 7, and then I'll be left with x minus 2 on the other side, giving 0, right? So again, one of the factors is this, the other factor is this, right? So that's option B. Okay, so I mean, like I said, there are many ways to do this, right? You could also use polynomial long division, but that's, you know what, that's just too much time. All right, so if you were able to spot this starting out, then also, you know, like the method I did initially, that's also cool. All right, because that will save you time actually. Okay, that's 59. Let's take 60. It says, given that y is equal to 1 minus 2x over 4x minus 3, find the value of x for which y is undefined. Okay, so y is undefined. Y is undefined when your denominator is 0. Any rational expression will be undefined when your denominator is 0. All right, so that's because you can't divide by 0. All right, or you can try, but your quotient will just shoot all the way up to infinity, right? You won't be able to find it at a particular location. You can test it out using limits, using your calculators, or even graphing, right? You can graph it to see. So there's that issue we have, that our denominator cannot be 0. So when you see questions like this, just go, okay, this is the culprit, right? This guy here cannot be 0. So we'll say, okay, what value of x will make this 0? That's the problem. So 4x is equal to, solve this, 4x is equal to 3. Divide both sides by 4. X is equal to 3 over 4. All right, x is, so it's the value of 3 over 4 that makes your function not defined. That's option, that was C, right? Positive 3 over 4. All right, so that's for question 60. Let's take question 61. All right, question 61 says, given that x plus 2 times x squared minus 3x plus 2 plus 2 bracket x plus 2 bracket x minus 1 is equal to, well, x plus 2 times m, find m. All right, so this seems like a very long thing to consider, right? But when you think about it properly, you would actually see that, you know, I can factor out x plus 2 from both groups, right? So let me use a different color for the addition sign in the middle. So we have two groups here. So I can factor out x plus 2. I would have x plus 2 out. Then from this side here, I would have, from the first one here, right, I'll be left with x squared minus 3x plus 2, right? And then from the second one here, I'll be left with 2 brackets x minus 1. All right, this is equal to x plus 2 times m. By comparing both sides of the equation, it's obvious to see that, okay, m, because this x plus 2 is this x plus 2, right? So m has to be everything inside this square brackets here. All right, so I have x squared minus 3x plus 2 plus 2 brackets x minus 1 is equal to m. Okay. Expanding and reducing that, I have x squared minus 3x plus 2 plus 2x minus 2 is equal to m. All right, so I can take out minus 2 and positive 2 will cancel out. I'll just be left with x squared here for this, and then minus 3x plus 2x. Minus 3x plus 2x gives you minus x. All right, that's equal to m. So I'm looking for something that says x squared
x squared minus x. I can't find that in the option, so likely there's an error. Um, there's an error in the question. Okay, that's for question 61. Question 62. Sorry. So question 62, we have, we're told that P is this and Q is that, and then Q minus P is 2, right? So Q minus P is equal to 2, all right? So that means that 2x minus 1, all right, then minus P, which is minus x squared plus 4x minus 2. So minus P is equal to 2. So we'd have 2x minus 1 minus x squared minus 4x plus 2 is equal to 2. All right. So collecting like terms, I would have minus x squared, because that's the only x squared variable here, right? And then for x, I'll have 2x minus 4x giving minus 2x. And then for the constant term, minus 1 plus 2 gives plus 1, right? Is equal to 2. So when I move this 2 over, I would have, just to make a standard quadratic equation that we can easily solve, I'll have minus x squared minus 2x plus 1 minus 2 is equal to 0. So final setup would be minus x squared minus 2x minus 1 is equal to 0. Okay, so I can solve this by factorization, right? I can solve this using factorization. Some people would have decided to maybe multiply the whole thing by minus 1 to make your, your a1 positive 1, which is more canon, but, we'll just run it either way. Okay, so b is minus 2, and then AC is positive 1, right? A times C, that's minus 1 times minus 1 is 1. And then B, the coefficient of the x term, right, is minus 2. Okay, good. We need two numbers that will add to give negative 2 but multiply to give 1. Those numbers would have to be minus 1 and minus 1, right? So minus 1 and minus 1. Okay, so they will multiply to give positive 1 but add up to give negative 2. So I can split up the current b value here, and my equation will look like minus x squared minus x minus x minus 1 is equal to 0. Okay, now we can group. From this, I can factor out minus x. So I have minus x brackets x plus 1. From this, I can factor out minus 1. I'll have x plus 1 also, right? So I have a rule to always factor out. If I have a negative coefficient starting out in either of my groups here, I would always factor out the negative sign, right? It just ensures that, okay, it kind of mitigates, against the issue of maybe having maybe having a negation of one of the binomials in one of the brackets, and then it can get a bit confusing, right? So I just always factor out negative sign if I see it first in either of the two groups. Okay, good. So this can be written as, I can factor out x plus 1, right? So x plus 1. And then from the first group, I'll have minus x. From the second group, I'll have minus 1 is equal to 0. Right? So I have the product of these two as 0. So that means that it's either x plus 1 is equal to 0, right? Or minus x minus 1 is equal to 0. So if x plus 1 is equal to 0, that gives x as minus 1, and if minus x minus 1 is equal to 0, that gives minus x as 1. When I divide both sides by minus 1 again, that makes x minus 1 also. So the solution is actually minus 1 twice, right? So the value for x that makes this statement true, that makes it such that q minus p is equal to 2 is x has to be minus 1. All right, x has to be minus 1. Okay, good. So that's for question 62. Let's take on question 63. If the sum of the roots of the equation is 1, find the value of p. All right, if the sum of the roots of the equation is 1, find the value of p. All right, so I'll expand, right? Or I can even solve for the roots, right? So instead of going that way, so we can solve for the roots. If x minus p is equal to 0, that means that x is equal to p, right? That's the first root. And then if 2x plus 1 is equal to 0, that means 2x is equal to negative 1, x is equal to negative 1 over 2. So these are our two roots. So we are saying that p plus minus half, right? So root 1 and root 2, their sum is 1. That means that p has to be 1, when I move this over, plus half.
right? Which gives me 1.5. All right, so the answer is A. Okay, so yeah, you could have chosen to expand, and then get, the whole standard form and then use the sum of roots relationship. That's fine, but then this is in factored form already, and I think probably faster and easier to just solve for the roots individually and then get your value for that. That's for question 63. I'm taking on 64 now. So we have 2x plus y is equal to 10 and y is not equal to 0. Which of the following is not a possible value for x? Okay, good. So if y is not equal to 0, and they're telling us for the one, the value of x that is also not a possible value, then we should solve for where y is 0, because that is, where the issue is, right? So we'll just plug in 0 and then solve for y. If we do that, we'll have 2x plus 0 is equal to 10. All right, again, the logic is simple. We are told that y cannot be 0. And then we are also asked for, a non-possible value for x. So we have to find the value of x that would work with this relationship, that can be disqualified by the statement itself. Okay, so we'll just have 2x is 10. So that means x is what? I can divide both sides by 2, right? X is 5. So it's quite an easy question, right? So that's 64. That's 64. All right, so let's take 65 now. All right, 65 says 2x squared plus kx minus 14, gives you that. 2x squared plus kx minus 14 gives you that. Find the value of k. Okay, so the easiest thing to do would just be to expand what we have on the right and then compare, right? So let's expand what we have on the right. We have x plus 2 multiplying 2x minus 7. All right, so let's do this right. So x times 2x gives you 2x squared, and then x times minus 7 gives you minus 7x. 2 times 2x gives you plus 4x, and then 2 times minus 7 gives you, that would be minus 14. That would be minus 14. So we have that. When I sum this up, I'll have 2x squared minus 2x squared minus 3x minus 14. 2x squared minus 3x minus 14. So comparing that to 2k squared, 2x squared rather, plus kx minus 14, it's obvious to see that k is minus 3. So just by comparing what we have here, right, k is minus 3, that's option C. Okay, that's 65. Let's go for 66. 66 says, if x squared plus 15x plus 50 is equal to ax squared plus bx plus c, which of the following statements is true? Okay, and it's also equal to 0. Okay, good, it's also equal to 0. All right, so which of the following statements is true? Okay, so the first thing is A is, by comparison, right, we can say A is 1. Okay, it's not true rather. So A is 1, B is 15, and then C is 50, right? Good. So we are told x is equal to minus 5 and this and that. So BC is this. BC, so this is true, right? Because this one we can test just by monitoring the terms, right? We can test just by monitoring the terms that, okay, B times C is true. But we need the one that is not true. So we need to check for the others by solving for the solution. So let's have x squared plus 15x plus 50 is equal to 0, right? Because, this is eventually equal to 0. We'll use factorization as usual. So we have B and then AC. Yeah, so two numbers that will add to get 15 plus, and then that will multiply to get 50. Those numbers have to be plus 10 and 5. All right, plus 10 and plus 5. So I can rewrite this statement here by implementing, I will have x squared plus 10x plus 5x plus 50 is equal to 0, right? A step further would be to now group. From this, I can drag out x. I'll have x bracket x plus 10. From this, I'll have, I can drag out 5 plus 5 bracket x plus 10 is equal to 0. Now factor out x plus 10 from both sides, right? So I'll have x plus 10. From the first group, I'll just have x. From the second group, I'll have 5 is equal to 0, right? So it's either x plus 10 is equal to 0 or x plus 5 is equal to 0. In this case, x equal negative 10. In this case, x would equal negative 5, right? So those are the two solutions. So you can come back here. This is true, right? And this is not true, right? X is equal to negative 10, not positive 10. And this is true, right? Because, if I drop one of the values, it's true for one of the values for x, right? So the correct option is D, all right? D is a statement that is not true, all right? X is not equal to 10. All right, so that's for question 66. Let's take 67. We have x minus a is a factor of that. Find the other factor. Okay, so good. So to factorize, right, we need to write express the terms, right, such that the product of the terms in the middle will be the same as the product of the terms at the end. All right, so and so we can test this out. That if I do this times this, it won't give me the same as this times that. This will give me x cubed something, right? But so that means I should rewrite it. And I think what could work is if I set up x squared here and minus ab here. All right, so I'll then have bx minus ax. All right, so if I set it up this way, it should work. All right, if I multiply the first term and the last term, I'll have minus abx squared. If I multiply the terms in the middle, I'll also have minus abx squared. So now we can factorize, okay? So let's split up down the middle. I can drag out x from the first set here. So x bracket x plus b, all right? And then from the next set here, the next group here, I can factor out minus a. So minus a bracket what? X plus b. So we have x plus b on both sides, so we can factor out x plus b. X plus b out. From the first group here, I'll be left with just x. From the second group here, I'll be left with just minus a. So this is the factored form. All right. So if we have x minus a already, the other factor should be x plus b, which is option D. X plus b, which is option D. All right. Question 68. Okay, good. So if c and k are roots of that, find c plus k. Good. So if c and k are roots, so one way to do this is to solve this out and then get the answers and then do that, right? But another way to do is just go with the formula, right? The formula that says x squared minus sum of roots times x plus product of roots is equal to 0. So this can be written as minus x squared, all right? Minus x squared minus x plus 6 is equal to 0. So I'm just writing it as, kind of like trying to put it in standard form, all right? Then to use this formula, the coefficient of x squared must be plus 1. So I can divide everything here by plus 1, right? To give me x squared plus x minus 6 is equal to 0. So x squared plus 1 x minus 6 is equal to 0. By comparison, my product of roots is minus 6. And then my sum of roots, so because of this negative sign here, right? So negative sum of roots is equal to positive 1. All right, so that means the sum of roots itself would be negative 1. All right, negative 1. So the answer is option D. Okay. So no qualms with you trying to solve, get the values for C and K and then, adding them up. That's fine. It's just, managing time, because if I wasn't actually having to teach this, I could have answered this question probably by just staring at it for a little while. So it's just a time saving thing. So that's for 68. Let's take 69. So 69 says x squared plus kx plus 16 over 9 is a perfect square. What's the value of x? Okay, so I think there's an error here, right? This should have said what's the value of k? All right, what's the value of k? Will be corrected. Okay, so we have x squared plus kx plus 16 over 9, right? So the rule for it to be a perfect square is that aside from a, you need to check and make sure that a is equal to 1. Then the other rule is that c is equal to b over 2 or squared. All right, so in this case, b is k, right? So we are solving for b basically. All right, so we have 16 over 9 is equal to b over 2 all squared, right? If I take square root of this, I would have 4 over 3, all right, is equal to b over 2. All right, so that's actually plus or minus 4 over 2, right? 4 over 3, right? Plus or minus 4 over 3 is equal to b over 2. So there are two solutions we could have. Sorry, let me come over here. I'm sorry, I'm having to move over here. But we have 4 over 3 is equal to b over 2, or minus 4 over 3 is equal to b over 2, right? If you multiply both sides by 2, cross multiply, whatever works for you, you shall end up with b is equal to 8 over 3. Right? If you do the same thing here to your b would be equal to what? Negative 8 over 3. So your answers are is either b is 8 over 3 or negative 8 over 3 by taking a. Okay? So again, it's just, the more familiar you are with your perfect square relationships, but it should be like the easier this kind of questions would be. That's for 69.
Right, question 71. In the quiz, a student answers n questions correctly and was given, this amount, n plus 15 naira for each question correctly answered. If he gets 600 naira altogether, how many questions did he answer correctly? So that means that, for each question he got n plus 50. But he answered n questions, right? So n times this gives you how much he gets in total. So this is the price for each. N plus 50 is the price for each. Right, so we can solve this. We just need to expand this. This would be tight. Okay, let's expand this. We'll have n squared plus 50n is equal to 600, right? That would mean that n squared plus 50n minus 600 is equal to 0. So we need to do the factorization thing here, right? So we need to split the middle value into two numbers that their product of those, the product of those two numbers would be the same as the product of the two, the product of those two terms, right? To be the same as the product of the terms at the end. Anyway, so b is 50, and then ac is minus 600, right? We need to think of two numbers that would add up to give 50 but multiply to give minus 600. Those two numbers would have to be 60 and minus 10. Right, 60 and minus 10. Sorry, so I'll pick this up now. So we have n squared plus 50n minus 600, right? And we're saying that the two values in the middle, what we split up 50 into would be n squared minus 10n plus 60n minus 600 is equal to 0, right? Just to make sure you can see. So n squared minus 10n plus 60n minus 600 is equal to 0. Okay, good. So now I can factor out n. I would have n bracket n minus 10. From this, I can factor out 60 plus 60 bracket n minus 10 also, right? So I can factor out n minus 10. I'll have n minus 10. From the first group, I'll have n. Second group, I'll have plus 60 is equal to 0. So one of them must equal 0, right? One of the two factors must equal 0. So if n minus 10 is equal to 0, that means that n is equal to 10. Or if n minus 10, if n plus 60 rather, is equal to 0, it implies that n is equal to minus 60. Alright, so when you think of what n means the number of questions that we answered correctly, right? So you can't answer negative 60 questions. So the correct option has to be 10, right? Plus 10. The answer is A. Alright, that's it for 71. Let's go 72.
All right, so for 72, we are told that we were asked to find one factor of this, right? So one factor of all of these is what? So we have is 7x squared minus 33x minus 10 that we are asked to factor, right? So we need to split up to group, we need to split up the value in the middle. All right, we need to set up the value in the middle such that the product of the values in the middle will be the same as the product of the values at the end. But there's a nice trick I use, right? Just b and then ac. The value for b is negative 33, and the value for ac is negative 70, right? So I just write back, and then after writing this out, then we have to find, okay, what value would we add to get b, but then multiply to get that. All right, looking at the factors of minus 70, I think we should be able to work with negative 35 and positive 2. All right. So yes, correct. So yes, correct. So that means we'll use this to fill up that space. Hence, this becomes 7x squared minus 35x plus 2x minus 10. Okay, so now we can split this up in two. From the first group here, I can factor out 7x. If I factor out 7x, I'll be left with x minus 5, right? From the next group, I can factor out plus 2. I'll also be left with x minus 5, which shows we are factoring nicely. Yes. So because I have x plus 5, x minus 5 here and x minus 5 here, right? So I can factor out x minus 5. So I have x minus 5, all right, out. Then from the first group here, I'll be left with 7x. From the second group here, I'll be left with plus 2. So the answer is x minus 5. I'm multiplying 7x plus 2. So the correct answer is, which of them is a factor? That's x minus 5. All right, x minus 5 is one of the factors. That's option D. Okay. Question 73 says one of the factors of this is m minus n. What's the other factor? Okay, we have mn minus nq minus n squared plus mq. Okay, good. So for you to be able to factor, right, by grouping, you must have it such that the product of the terms in the middle is same as the product of the terms at the end. And looking at it, this doesn't produce that kind of scenario, right? So it wouldn't work, right? We can't factor this way. We need to rearrange. And I think to just switching here and here should get us to where we need to be, right? So let's do that. We have mn minus nq plus mq minus n squared. If you multiply what you have in the middle, wouldn't work actually. No, it wouldn't work. Okay, so let's start with mq then. And I'm doing all of this on screen so you can see, So we have mq plus mn minus nq minus n squared. Right? So I think this should work, because if you multiply the n terms, we'd have n squared mq minus n squared mq if you multiply this and this, right? Then if you multiply the terms in the middle, you have minus n squared mq also. Yes, so it works, right? So you need to always do that test, that the product of the terms in the middle is same as the product of the terms at the end. All right, so and I had to go through a few iterations to get that. Okay, so we can now group, right? Since we have that, we can group. We can factor out m, and I'll be left with what? Q plus n. Yeah, I can factor out minus n, right? So if I ever have a negative sign leading either of my groups, I factor out the negative sign also, so minus n, and I'll be left with q plus n. All right, so I can factor out q plus n, and then from the first group, I'll be left with m. From the second group, I'll be left with minus n. So the answer is q plus n, m minus n. So if we already have m minus n, then the correct answer is q plus n. That's option B, right? N plus q. All right. Yeah, so we have that. Let's take 74. Okay, 74 says one of the roots of the equation, this is, okay, so we are asked to solve for the root. So 6x squared is equal to 5 minus 7x. All right. Okay, so the first thing you want to do is you want to just rewrite everything. So I have 6x squared plus 7x minus 5 is equal to 0, because this is the standard form that allows us to pick out, our a, b, and c. Okay, good. So we can begin with this, right? What's my value for b? My value for b is 7, right? And my value for ac is minus 30, right? So b is 7. So we do this because just to make it easy for us to identify what we need, right? So we just write back b is 7, write that, and then a times c is minus 30, right? The next goal now will be to find out two numbers that we can add to get b, but then multiply to get a times c. Okay, so it has to be 10 and negative 3, right? Yeah, those are the two numbers that would work. So we can come back now, we write this guy, right, by splitting up the positive 7 in the middle into these two numbers. So we have 6x squared plus 10x minus 3x minus 5 is equal to 0. Okay, so once you've successfully done this, you should be able to group easily, right? Because the product of the terms in the middle is now exactly the same as the product of the terms at either end. Okay, we can drag out 3x. Yes, so So 3x, and then we'll be left with 2x plus 5. Sorry, I can drag out 2x, my bad. Sorry. Yeah, I can drag out 2x, not 3x, right? So I can drag out, I have 2x bracket. So this will now be 3x plus 5, good. And then from this group here, I can factor out -1, and I'll be left with 3x plus 5 is equal to 0, right? Good. So because I have the same thing, the same binomial in the brackets, right, I can factor out 3x plus 2. So 3x plus 5 rather, right? I can factor out one of the brackets because it's the same thing in both for both groups. So 3x plus 5 comes out, and then I'll be left with, from the first group, I'll be left with 2x. Second group, I'll be left with -1 is equal to 0. Okay, so these two factors multiply themselves to give you 0. So that means one of them must be 0, right? So it's either 3x plus 5 is equal to 0, or 2x minus 1 is equal to 0, because that's the only way that they would multiply to give 0. Okay, so bringing that over here, if I have 3x plus 5 as 0, that means 3x is equal to -5, and then x is equal to -5/3. Or if I have 2x plus 1, 2x minus 1 is equal to 0 rather. If I have 2x minus 1 as 0, right, the second culprit, then that means that 2x would equal 1 and x would equal 1/2, right, when I divide both sides by 2. So the correct option is option A. All right, so 75 says simplify 2x squared plus 5x minus 12 over 4x squared minus 9. All right, so we need to rewrite top and bottom, factorize it, and we'll see what it probably simplifies to, right? Okay, so we have 2x squared plus 5x minus 12 divided by rather 4x squared minus 9. Okay, so we'll do the numerator here, the factoring, and then we'll do the denominator right under. Right, so for the numerator, we have 2x squared plus 5x minus 12, right? So we need to be able to group, we need to split up the middle value, right, into two numbers or two terms that have the same product as the terms on the extreme. All right, so B and AC, that's my hack, so back. So two numbers we can add to get B, but then multiply to get 8C, right? So B is 5 and AC is -24. The two numbers we can use, factors of 24, 8 and 5, right? So 8 and -3 rather. So 8 times -3 gives -24, and 8 plus -3 gives 5. So I can rewrite this as 2x squared plus 8x minus 3x minus 12. I can factor out 2x from the first. I would have x plus 4. From the second part, I can factor out -3. So I always factor out the negative sign, right, if I have one in front. So -3 bracket x plus 4, all right? -3 in -12 will give you +4. So I have x plus 4, for both, right? So I will factor out x plus 4, right? And then from the first group here, I'll be left with 2x, and from the second group, I'll be left with -3. That means that what I have on top is actually, x plus 4 times 2x minus 3, right? So that's the numerator. So over, let's factor the denominator. The denominator is 4x squared minus 9. So let's factor out 4x squared minus 9. This is a difference of two squares scenario, right? Now we have a squared minus b squared is equal to a plus b multiplying a minus b. So it's very easy to see, right? Yeah, it is very easy to see because this is 4x squared is a square term, right? And then 9 is a square to an difference of two squares. So you must build familiarity with your difference of two square relationship and be able to spot them. Okay, anyway, so this is 4x squared minus 9. So a plus b, which would mean the roots of a squared and b squared, right? In this case, 2x squared and 9 would be 2x. All right, so square root of 4x squared is 2x.
and then square root of 9 is b. So 2x plus 3 times 2x minus 3. This will be 2x plus 3 times 2x minus 3. So 2x minus 3 will cancel out, right? So we'll be left with x plus 4 over 2x plus 3. That's option C. X plus 4 over 2x plus 3. That's option C. All right. So we are asked to solve for x given this, right? To solve for x given that. Solve for x given that x squared plus 2x plus 1, I mean, you can take out the bracket, right? It really means nothing, is equal to 25. All right, so I'll set this up in my standard form by moving to, 25 over to the other side. So I'll have x squared plus 2x plus 1 minus 24, right, is equal to minus 25, my bad. Minus 25 is equal to 0. So I'll have x squared plus 2x minus 24 is equal to 0. Okay, so we can try to factor this by grouping, which means that we'll have to rewrite the middle value here. Write it as two terms that their product is same as the product of the two terms, right, at either end. So, well, the hack we have for that is just, okay, let's write this BAC. So write back. The value for B is 2, the value for A times C, that's 1 times minus 24, minus 24. Okay, next thing is what can we, the next now is what can we use, what two factors that multiply to give minus 24 would also add to give 2. We have to use 6 and 4. I'm thinking 6 and minus 4, all right? Yes, because they multiply to give minus 24 and add to give 2. Hey. All right, so we can write this as x squared plus 6x, right? Minus 4x minus 24 is equal to 0. You can check to be sure, right, that the product of the terms in the middle is same as the product of the terms at either end, right? So anyway, since we have it this way, that means we can go on to group. So for the first group, we can factor out x. We'll have x bracket x plus 6. From the second group, we can factor out negative 4. I make it a point of duty that if I have a negative leading coefficient, right, for either group, I will factor out the negative sign alongside. Okay, so minus 4 bracket x plus 6 is equal to 0. So we have x plus 6 here and x plus 6 here. So I can factor out x plus 6. From the first group, I'll be left with just x. From the second group, I'll be left with minus 4 is equal to 0. Good. So we have the product of these two giving 0, meaning that one of them must be 0, right? Because only with two factors can multiply themselves to have a product of 0 is if one of them is 0. So if x plus 6 is equal to 0, that means that x will equal negative 6. Or if it's the other factor, right, if x minus 4 is equal to 0, that means that x will equal 4. So the solutions, the roots, of this minus 6 and positive 4. That's option D. Option D. That's for 76 rather. Let's take 77. 3a plus 10 is equal to a squared. So 3a plus 10 is equal to a squared, right? So I can rewrite this by, moving 3a and 10 over so that I just have it in standard form. So that would be a squared minus 3a minus 10 is equal to 0. All right. So the next thing we want to do now is I think we should try to solve by factoring, right? So we need to group, we need to split up the value in the middle, such that the two new values we get would have the same product as the two, values at the end. All right. To do this easily, I just write back. All right. BAC. B is negative 3, and then A times C is 1 times minus 10, that's minus 10. Then we need to think of two numbers that would add to give us B, but multiply to give us, AC. Okay, good. So the factors of minus 10 that would work would be 5 and minus 5 and plus 2, right? So that would work because it multiplies to give -10 but adds to give -3. Good. So we can come in here and replace this as a squared minus 5a plus 2a minus 10 is equal to 0. Right, so a squared minus 5a plus 2a minus 10 is equal to 0. We can factor out a from here, right? If I factor out a from the first group, I'll have a bracket x minus 5, all right? Sorry, a bracket a minus 5, sorry, I'm used to x. A bracket a minus 5. And then from the second pair here, right? From the second pair here, I'll factor out plus 2. I would also have a minus 5 is equal to 0, right? Since I have a minus 5 and a minus 5 here, I can go on to factor a minus 5 from the entire thing, all right? Now I'll have, from the first group, I'll have a. From the second group, I'll have plus 2 is equal to 0. All right, so we're nearly there. We've come to the point where we have two factors, all right, that multiply to give 0. The only way that will be the case is if one of them is 0, right? So it's either a minus 5 is equal to 0 or, well, then a plus 2 would equal 0. At least one of those should be true. If I solve the first option, I'll have a as 5. Solve the second option, I'll have a as -2, right? So the answer is a is equal to 5 or a is equal to -2. That's option C. A is equal to 5 or a is equal to -2. All right. So for this, we are asked to solve the equation. We are asked to solve the equation. We have x plus 2 times x minus 7 is equal to 0. Okay, so to solve this, we would only have to just equate each of them to 0, right? Because the only way the product of both of them would be 0 is if one of them is 0. So that means that it's either that x plus 2 is equal to 0 or x minus 7 is equal to 0. If x plus 2 is equal to 0, that means x is minus 2. Or if x minus 7 is equal to 0, that means x is 7. Right? So when you solve each one, so the correct answer is minus 2 or positive 7. Right? X plus 2 is equal to 0. Okay, let me erase this and write it again. X plus 2 is equal to 0, that means x is equal to minus 2. So they already gave us in factored form, right? So we just use the relationship that if product of both of them is 0, then one of them must be 0. I think the correct option is option B, minus 2 or 7. All right, that's for question 78. Let's take 79. 79 is asking us to solve 79 is asking us to solve 10 minus 3x squared, 10 minus 3x minus x squared is equal to 0. So 10 minus 3x minus x squared is equal to 0. The easiest thing to do here is I'll just move everything to the other side or multiply it through by -1. That I have, a more familiar terrain to work with, right? So I'll move everything to the other side. So when I move x squared over, I would have negative x squared, I'll have positive x squared. When I move negative 3x over, I will have positive 3x. When I move 10 over, I'll have negative 10. That's equal to 0. Okay? So we can solve by factoring. By grouping, right? Factoring grouping here. So we just need to rewrite 3x such that the product of the values would be the same as the product of x squared and minus 10, right? So the product of the two values we'll have in the middle must be the same as the product of the values we have at the end. The hack I use, I just write B, A, C and write them out. So B is 3 and A times C, that's 1 times minus 10 is minus 10. All I have to do now is find two values that add up to 3 but then multiply to give -10. Okay? So write your back, BAC. Think of two values that will add up to give you whatever the value for B is, but then multiply to give you whatever the value of A times C. Working with the factors of -10, I think we need 5 and -2. Yes, 5 and -2, good, works. So this is going to be x squared, all right, plus 5x minus 2x minus 10 is equal to 0, right? So I can factor out x from the first group. If I factor out x, I would have x bracket x plus 5 And I can factor out minus 2 from the second group. I have minus 2 bracket x plus 5. All right. So I always factor out the negative sign. Always factor out the negative sign from if the negative sign is leading either of my groups, right? I factor out the negative sign. Okay, good. So I can factor out x plus 5 since I have x plus 5 here and x plus 5 here. I factor out x plus 5. From the first group here, I'll have just x. And then from the second group here, I'll have minus 2 is equal to 0. All right, we've been able to successfully rewrite the system as, well, a product of two factors that equals 0. Right? So to solve this, we just say, oh, either x plus 5 is equal to 0 or x minus 2 is equal to 0. And that's because if two factors would multiply themselves to give 0, then at least one of them must be 0, right? So solving the first one here, we have x is negative 5. Solving this second one here, we have x is 2. So the answer is x can be negative 5 or 2. That's option C, 2 or negative 5. Okay, that's 79. Let's take 80. 80 says solve the equation. Okay, so solve the equation, we have 2x squared. Oh, sorry, 2a squared. So 2a squared minus 3a minus 27 is equal to 0. So 2a squared minus 3a minus 27 is equal to 0. 2a squared minus 3a minus 27 is equal to 0. Okay, good. We can solve this by factoring, right? We need to rewrite the values we have in the middle. We need to rewrite these values such that the product of the two values will be the same as the product of the values at either end, right? So the product of the two values we are going to come up with must have the same product as this and this, right? So how do we do that? Well, the hack we use is we write b and then ac, right? Back. The value for b is negative 3, so they must add up to give this value for b. But then a times c, that's minus 54. Then the two numbers must also multiply to give you that product of ac minus 54. Yes, minus 54. So the values we can use would have to be minus 9 and 6. All right, because if you add them up, it gives negative 3. Multiply them, yes, so we're correct. That means we can go on to rewrite this now. Okay, so I'll have 2a squared minus 9a plus 6a minus 27 is equal to 0. From the first group here, I can factor out a, just a, right? From the first group here. If I do that, I would have 2a minus 9. And then from the second group, I can factor out plus 6. Rather, plus 3, my bad. Plus 3, okay? Yeah, I can factor out 3. I would have 2a minus 9 also is equal to 0. All right, so from where I am, that means that I can factor out 2a minus 9, right? Because 2a minus 9 exists in both of them. If I factor out 2a minus 9, from the first group here, I'll be left with just a. From the second group here, I'll be left with plus 3 is equal to 0. So we have successfully written the equation as a product of two factors that give 0. So that means that one of the factors must be 0. So it's either 2a minus 9 is equal to 0 or a plus 3 is equal to 0. And it's a valid statement, right? It's a valid statement because that's the only way two values will multiply themselves to give you 0. One of them must be 0. At least one of them must be 0. Okay, so we have 2a is equal to 9, or a is equal to 9 out of 2, or, continue the or statement for the other, a is equal to negative 3, right? A is equal to negative 3, so the answer is negative 3 or 9 over 2. That's option D. All right. That's question 80. Let's take question 81 now. Let's take question 81 now. Question 81 says solve 3 plus 5x minus 2x squared is equal to 0. Okay. So my move would be, I'll just move everything over, right? And I'm doing that just so that my leading, because 2x squared, I want that to be positive, right? So since it's equal to 0, it's easy enough. So I'll rewrite this, moving everything over. You can solve it without doing that. That's fine. You know, you're careful enough, you will get the correct answer, right? But I like to have a positive coefficient. So I would work 2x squared minus 5x minus 3 is equal to 0. So I just moved this, became positive, this became negative, this became negative, and it's equal to 0. Okay. Yes. So BAC, right? And the reason why we're doing this is because we want to split up this value in the middle to give us two numbers that would, their product, right? Their product would be the same as the product of the values at the end. That's the requirement for grouping, all right? That the two values in the middle we are getting would have the same product as the two values at the end. That's, in this case, 2x squared and negative 3. Anyway, this little hack helps us to get there. B is negative 5. And then AC, that's 2 times minus 3, that's minus 6. So we need two numbers that would multiply to give negative 6 or add to give negative 5. Those two numbers would have to be, I think that will be negative 6 and positive 1, right? Negative 6 and positive 1. Okay, good. So we can rewrite this. We'll have 2x squared minus 6x plus 1x, that's plus x, minus 3 is equal to 0. All right? Is equal to 0. Split this up for grouping. We can factor out 2x. To factor out 2x, from here, I have 2x bracket x minus 3. I factor out 1 plus 1, I would have x minus 3 also is equal to 0. So I have 2x plus 1 times x minus 3 is equal to 0. So what do we have here? We have the product of two factors being 0. The only way two values can multiply themselves to give 0 is if one of them is 0, right? So, and by that, we have the right to say it's either 2x plus 1 is equal to 0 or x minus 3 is equal to 0. If the first is the case, we have 2x as negative 1. That means divide both sides by 2. X would equal negative 1 over 2. If x minus 3 is equal to 0, you know, I can move the minus 3 over, so x would equal 3. So the solution is x could be 3 or x could be negative half. X could be 3 or negative half, that's option D. All right, that's option D. All right, that's for 81. For 82, good. 82, we have solve the equation. Solve the equation, we have 3x squared plus 25x minus 18. So let me write this up here. 3x squared plus 25x minus 18 is equal to 0. Okay, so we need to rewrite it. If we want to solve by factoring, right, we need to group. And to group, we need to split the middle term into two values. That the product of those two values will be the product as, you know, same product as the values on the end, right? That's 3x minus 18. Anyway, there's a nice hack. We just say B and then AC, write it out. So B is 25. 8 times C, that's 3 times minus 18. That's 54, right? That's 54. Negative 54 actually in this case. Okay, so negative 54. Okay, so what two values could or do multiply to give negative 54 and then add to give 25, right? So that's the hack there. Thinking of the factors of 54, I think we need to go 27 and 2. So this would be positive 27 and negative 2. All right, so you can try that. If you add them, you get 25. If you multiply them, you get negative 54. So I would rewrite this line, replacing 25x, I'll rewrite it as what? 3x squared. So we'll have 3x squared plus 27x minus 2x minus 18 is equal to 0. What can I factor from the first group? From the first group, I can factor out 3x, right? So I have 3x. So I have 3x bracket x plus 9. From the second group, I can factor out negative 2. This would be x plus 9 also, right? Is equal to 0. Okay. I can factor out x plus 9. Okay, if I drag out x plus 9, I'll have x plus 9. In the second group, I would have, from the first group, when I factor out x plus 9, I'll be left with 3x here. And then from here, when I factor out x plus 9, I'll be left with minus 2 is equal to 0. Okay, good. So we have successfully rewritten the system, right, as a product of two factors, that is 0. So the product of two factors is 0. And we know that, of course, if two numbers multiply themselves to give you 0, then we have a right to claim that at least one of them would be 0. All right. If not, there's no way two numbers can multiply themselves to give 0. So we'll have x plus 9 is equal to 0. That's the first option. Or the other factor, we could try that. 3x minus 2 is equal to 0. If x plus 9 is 0, that means x is negative 9. If 3x minus 2 is 0, that means 3x is equal to 2. We can divide both sides by 3 to get x as 2 over 3. Right? So we have x is equal to minus 9 or x is equal to positive 2 over 3. That's option D. All right, so we're getting there. That's 82. For 83, we have solve the equation 3y squared is equal to 27y. Okay, so 3y squared is equal to 27y. All right, so I'll start by telling you what not to do. Do not divide both sides by 3 and then, try to divide both sides by y or something like that. No, you would lose one of your solutions. Okay, so what you want to do is you want to move 27y over, to have like a quadratic equation. So we'll have 3y squared minus 27y is equal to 0. So this is a quadratic equation. We just don't have a constant term. But that's fine. We can still factor. All right. We just factor, by, taking out the HCF. So this will be 3y, right? Bracket y minus 9 is equal to 0. Okay. And then we can now say, well, if the two values multiply to give you 0, then one of them must be 0. So that would be either 3y is equal to 0 or y minus 9 is equal to 0. So either and divide both sides by 3 here, right? So I'll get y is equal to 0. Or if I move minus 9 over, I would have y is equal to positive 9. So the solution is y could be 0 or y could be positive 9. Okay. All right, so question 84. Question 84 says 7y squared is equal to 3y. All right, so 7y squared is equal to 3y. So I'll start by saying what not to do, right? Do not divide both sides by y. You will lose one of the solutions. Instead, move the 3y over, all right, so that we can set it up like a quadratic equation. So 7y squared minus 3y is equal to 0. So this is like a quadratic equation, but there's no constant term. All right. So to solve this, we can factor, just factor, but not by grouping now. We'll factor out by collecting the highest common factor, right, which is y. So I'll say y bracket 7y minus 3 is equal to 0. So I now have two possible values for 0. I have y is equal to 0, right? So is that the first one is 0 or 7y minus 3 is equal to 0, right? So y is equal to 0 or this would be 7y is equal to 3. So divide both sides by 7. Y is equal to 3 out of 7. Your solution is y could either be 0 or be 3 out of 7. That's option B. Y could be 0 or 3 out of 7. Okay, let's take on 85. 85 says solve the equation. We have to solve the equation x squared minus 2x minus 3 is equal to 0, right? So x squared minus 2x minus 3 is equal to 0. Okay, good. So I can split up what we have in the middle into 2, right? I have to do that. Split it up into 2 such that the product of the two values in the middle is same as the product of the two values at the end. There's a neat trick for that. Just write back. My value for b is negative 2. My value for a times c, well, that will be 1 times negative 3. That's negative 3. Okay? And we only need to think of two numbers that would add to give us negative 2, but then multiply to give us negative 3. Those two numbers would have to be, okay, so those numbers will have to be negative 1 and, no, 3 and negative 1. Yes, 3 and negative 1. No, negative 3 and 1.
right? Negative 3 and 1, because they multiply and then they add to give you. Okay, so that's fine. Okay, good. So we'll rewrite this, right? Would have would have x squared in place of this minus 2x would have minus 3x plus x minus 3 is equal to 0. All right, so what we've achieved is we have rewritten the original equation in a manner that allows us to factor. All right, and the rule for that is that the product of the terms in the middle is same as the product of the terms at either end. Okay, so from this first group here, I can factor out x. When I factor out x, I would have x bracket x minus 3. And then from the other group, I can factor out plus 1 bracket. Then when I factor out x minus 3 is equal to 0. Apologies for squeezing in. So I can factor out x minus 3, right? Let me do that here. I can drag out x minus 3 because x minus 3 is common to both groups. So x minus 3 out of the first group here, I'll be left with just x, and x minus 3 out of the second group here, I'll be left with plus 1 is equal to 0. We have successfully rewritten the equation, right, as a product of two factors, which is 0, right? So if two factors have a product of 0, then one of them must be 0. We either have it such that x minus 3 is equal to 0, or we have it that x plus 1 is equal to 0, right? So x is equal to 3, or x is equal to negative 1. So we're looking at x is 3 or x is negative 1. That's option A, right? Yes, option A. All right, moving on. We're taking on 86 now. So 86 says that 2x squared minus x minus 6 is equal to 0. So let's do that. 2x squared minus x minus 6 is equal to 0, and we have to solve the equation. All right, so we'll solve by factoring. I have a trick here. I write b and then ac. All right. So what I'm doing with this is that it's going to allow me to rewrite the middle term as a product of two factors. As the sum of two numbers rather. All right. But then the cool thing is that those two numbers I would have here, that would replace the minus 1x. Their product would be the same as the product of the numbers at the end. All right. So that's for you to be able to group. That must be the case. That the product of the values in the middle must be the same as the product of the values at either end. Okay. So let's do this. B is negative 1, and then a times c, that's 2 times minus 6 is minus 12. All right. So b is negative 1, and then a times c, 2 times minus 6 is minus 12. So we need two numbers that will add to give us, negative 1, but then multiply to give us, negative 12. The two numbers we can use would have to be negative 4 and 3, right? Negative 4 and positive 3. So we'll use those two numbers now to replace our value for b. So we'll have 2x squared minus 4x plus 3x minus 6 is equal to 0. Okay, so once we've written it out that way, we're good, right? We can now go on to group. From the first group here, I can drag out 2x, right? I can drag out 2x and I would have x minus 2. Good. From the second group here, I can drag out 3, okay, plus 3, and I would have x minus 2, right, is equal to 0. Since I have x minus 2 here and here, right, so I can factor out x minus 2 itself. Factoring out x minus 2 from the entire thing here, the first group I'll be left with 2x, and the second group I'll be left with plus 3. So that means, I have written the function now as a product of two factors, all right, with a product of 0. So if the two factors multiply themselves to give you 0, then one of them must be 0, right? That's the only way. There's no other way you have two values multiplying themselves to give 0 if neither of them is 0. So at least one of them must be 0. Is either x minus 2 is equal to 0, or 2x plus 3 is equal to 0. From the first one here, we have x has to be positive 2. From the other, we have 2x has to be negative 3. So x has to be negative 3 over 2. So we're looking at x is negative 3 over 2 or 2. That's option B. All right, let's move on to 87. Okay, so for 87, we have 5x squared. For 87, we have 5x squared minus 4x minus 1 is equal to 0, right? So 5x squared minus 4x minus 1 is equal to 0. We are asked to solve. All right, so I'll solve by factoring. Sorry. I'll solve by factoring. To factor, right, we'll write b and ac. I like to write back so that I can see exactly, what I'm looking for. Now we need to be able to rewrite the equation such that we'll replace the value in the middle here with two values, right, two terms, that have the same product as 5x squared and minus 1 does. So the product of the two values in the middle will be the same as the product of the two values at the end by the time we're done. Okay, anyway, BAC helps us to do that, right? Just write back. My B is -4 and my A times C, that's 5 times -1, that gives me -5. So my job now is to look for two numbers that add to give me B, but multiply to give A times C. Okay, so those two numbers would have to be -5 and +1. Right, so -5 and +1. So with that now, I can come back here and rewrite this entire sequence, right, as 5x squared minus 5x plus x minus 1 is equal to 0. All right, and with this now, I can group. So from the first group here, I can factor out 5x. So let me do that here. 5x out of this, I'll have x and -1, so x minus 1. From the second group, I can factor out +1, all right? And then I would have x and -1. Good, great. Now we have x minus 1 occurring in both terms. So that means I can factor out x minus 1, right? If I factor out x minus 1, I have x minus 1. Then I'll have 5x here, and then when I divide, I'll have +1 is equal to 0. So we've been able to successfully rewrite the equation, right, to a product of two factors, and the product is 0. So it means that one of them must be 0. It's either x plus 1 is 0 or 5x plus 1 is 0, right? Because that's the only way you can have two values multiplied to give you 0, is if at least one of them is 0. Okay, good. So it's either x minus 1 is equal to 0 or 5x plus 1 is equal to 0. If x minus 1 is equal to 0, that means that x is 1. But if 5x plus 1 is equal to 0, that means 5x would equal -1 when you move -1 over. And then when you divide both sides by 5, you have x as -1 over 5. Okay, so we're looking at -1 over 5 or 1. 1 or -1 over 5. So that's option A. Option A is correct. All right, that's 87. 88, we're asked to solve the following equation. We have 6x squared minus 7x minus 5. So we have 6x squared minus 7x minus 5 is equal to 0. Good job. So we're going to factor by grouping, right? And to do that, we need to rewrite the value in the middle. Okay, we need to rewrite the value in the middle such that we'll write it as two values, and then those two values must have the same product as the values at the end here. So that's actually the rule for grouping, that the product of the values, the product of the values in the middle would be the same as the product of the values at the end. Okay, but there's a neat trick we can use for this, right? We just need to come and write back b and then a c. My value for b in this equation is -7. My value for a times c is -30. All right, so we just need two numbers that will add to give us -7, but then multiply to give us -30. Okay, those two values would have to be 10 and 3, precisely -10 and +3, right? Good. So we've gotten the two values. Those two values would work, to replace the value for b we currently have. So I'll rewrite this whole sequence as 6x squared minus 10x plus 3x minus 5 is equal to 0. All right, so we've written this properly, and now we can now go on to group, split them in two. Okay, good. From the first group here, I can factor out 2x, right? That's what's common to both of them. So 2x bracket 3x minus 5. And then from here, from the second group here, I can factor out plus 1, right? That's all that is common there. And I'll have 3x minus 5. Apologies, the space is tiny, is equal to 0. So, sorry, let me just come down here and rewrite this here, right? So I have 2x bracket 3x minus 5, then plus 1 bracket 3x minus 5 is equal to 0. Okay, so we have more space now. Okay, 3x minus 5 is common, all right? So I can factor out 3x minus 5. If I factor out 3x minus 5, I'll have 3x minus 5 out. From the first group here, after taking out 3x minus 5, I'll be left with 2x. And from the second group, after factoring out 3x minus 5, I'll have plus 1. So I have the whole system rewritten as, a product of two factors, and that product is 0. So if we have two products, two values with a product of 0, then that means that one of them must be 0, right? So it's either 3x minus 5 is equal to 0, or 2x plus 1 is equal to 0. So if 3x minus 5 is equal to 0, 3x is equal to 5, x is equal to 5 over 3. Or if 2x plus 1 is equal to 0, 2x is equal to negative 1, x is equal to negative 1 over 2. So we have 5 over 3 or negative 1 over 2. That's option A. In question 88 is A. X is equal to 5 over 3 or x is equal to negative half. All right, that's question 88. Question 89 says, the relation y is equal to x squared plus 2x plus k passes through the point 2, 0, find the value of k. Okay, good. So on the graph, right, if you're given this kind of question, that means that at some point, when x is 2, y is 0, right? So it's okay to just plug in these two values, 2 and 0 in here, and then solve out to see what we get for k, right? So rewriting it, we have y is equal to, let me scroll down properly. Okay, so y is equal to 2x squared, x squared. Y is equal to x squared plus 2x plus k, right? But we are also told that when x is equal to 2, right, y is equal to 0, okay? And we know that because, like I said, this point here, it's saying x is 2 and y is 0. Okay, good. So we can plug this in and then solve, right? So we substitute, we'll have, so substituting, would have 0 is equal to 2 squared plus 2 by 2 plus k. All right, so 0 would be equal to 4 plus 4 plus k. 0 is equal to 8 plus k. And solve this by moving k over to the other side. So I'll have negative 8 is equal to k. Sorry, negative 8 is equal to k. Where's my eraser? Okay, yeah. So negative 8 is equal to k. So that's all, right? The value of k is negative 8. Option D. Okay, that's it for 89. Then let's go to 90 now. 90 says, so the roots of a quadratic equation are given as negative half and 2 over 3. Find the equation. So we have the standard expression for a quadratic equation is given as x squared, right? That's in terms of the roots, is x squared minus sum of roots then plus product of roots, right? Plus the product of the roots is equal to 0. So that's the standard form of a quadratic equation. So that means that I can actually rewrite this by saying x squared minus, so for the sum of the roots, right, this is the first root alpha, second root beta. So for the sum of the roots, I can solve that here. and then for products. Okay, so let's just solve for the sum and the product first before we plug it back in. Yeah. So for the sum, it's going to be negative 1 over 2, negative 1 over 2 plus 2 over 3. All right. The LCM is 6. 6 in 2 is 3. 3 times 1 is negative 3 plus 6 in 3 is 2 times 2 plus 4. So I actually have 1 over 6 here. All right, that's the sum. And then for the product, it's going to be negative 1 over 2 times 2 over 3. All right, so that's going to be negative 2 over 6. All right, or you could say negative 1 over 3. All right, okay, so let's just do negative 1 over 3. Let's reduce it, right? So here 1, here 3, so minus 1 over 3. Okay, so coming back to sub in, we'll have x squared minus sum of roots. Our sum of roots is 1 over 6. All right, x. Then plus product of roots is negative 1 over 3 is equal to 0. So that's the answer. All right. X squared minus 1 over 6x plus, well, or minus actually. So plus times minus is minus, right? So minus 1 over 3 is equal to 0. But you see, in our standard form, we do not like to have our expression or our equation have, with denominators. So we can choose a convenient value to multiply the whole thing by. That will take off all the denominators. Typically, that's the LCM of the denominators, right? So so I'll multiply the whole thing by 6. If I multiply the whole thing by 6, 6 times x squared leaves you with 6x squared. 6 times negative 1 over 6 would just give you minus 1, so that's minus x. And then 6 times negative 1 over 3 will give you minus 2 is equal to 0. All right, so we should be looking for the equation that is 6x squared minus x minus 2 is equal to 0. Okay, so that's option A. Okay, so it's not difficult at all. Not difficult at all. It's just x squared minus sum of roots, x plus product of roots is equal to 0. Solve for your sum, solve for your product, and then you substitute. The last thing is that sometimes you might have your denominator. You might have denominators, and so you need to get rid of the denominator. So just look for any suitable value and multiply through. Usually the LCM of denominators that would cancel out all the denominators, right? Such that you not have it in the proper standard form. Okay, that's question 90. Let's take question 91. 91 says that the roots of a quadratic equation are 4 over 3 and negative 3 over 7. Right? So the roots of a quadratic equation are 4 over 3 and negative 3 over 7. So standard is x squared. Right? So we have x squared minus sum of roots. So minus sum of roots x, then plus product of roots is equal to 0, right? So x squared minus sum of roots x plus product of roots is equal to 0. Okay, so let's solve for the sum somewhere and the product, right? Space. Okay, so let's do sum and product here. So my sum, so that'll be, this is alpha and this is beta, right? So these are my two roots. The sum, I would just say 4 over 3 plus negative 3 over 7. 4 over 3 plus negative 3 over 7. So plus times minus is minus, right? Because of space, I'll just do all of that. So minus 3 over 7. The LCM here is 21. 21 divided by 3 is 7. 7 times 4 is 28. Minus 21 divided by 7 is 3. 3 times, that's 9. All right. So I have 28 minus 9 gives me 19 over 21. So that's my sum. Okay. So I have x squared minus 19 over 21x. So let's go and get the product now, right? And plus, so let's get the product. I need the space, so I'm going to wipe off this calculation. So let's get the product, or the product of the roots. For the product of the roots, we're going to have 4 out of 3, so 4 over 3 times negative 3 over 7, right? I think we can cancel out. 3 will cancel out negative 3, so we'll end up with negative 4 out of 7, right? So plus minus 4 over 7 is equal to 0, right? So yeah, so we have that. So plus minus 4 over 7 is equal to 0. So we have our x squared minus the sum of roots, we calculated that, and then the product of the roots, we have calculated that. So just, taking care of the signs, we'll have x squared minus 19 over 21x, then minus 4 over 7 is equal to 0. So we're nearly there. All right, we're nearly there because, this is actually correct, but the only issue is that with our standard form, we don't like to have denominators. So we'll multiply the entire system by the LCM of the denominators. Just that's a suitable number that cancels out all the denominators, right? So here we have 21 and 7 as denominators. The LCM of 21 and 7 is 21. So I'll just use 21 to multiply through. 21 times x squared is 21x squared. 21 times all of this will just leave me with minus 19x, right? Because the 21 I'm multiplying by would cancel out the 21 under. And then 21 times minus 4 over 7 would leave me with minus 12, all right, is equal to. So let me do this last one. Let me do it here. That's 21 times negative 4 over 7. So 7 here 1, 7 here 3, right? So 3 times minus 4 is minus 12. So this is the final equation, right? That's the final equation right there. All right, so 21, my bad. So 21x squared minus 19x minus 12 is equal to 0. Okay, that's for, sorry, that's option A. Okay, good. That's option A. Okay. Right. So that's for question 19. Let's take on question 91. Let's take on question 92. It says, so the sum of two consecutive whole numbers is 5 out of 6 of their products. Find the numbers. So that means that if they're consecutive whole numbers, then we'll describe them as n and n plus 1, right? So that's two consecutive whole numbers. It's like saying 5 and 6, just two numbers that follow each other. Okay, so we can describe them that way, and then we can, so their sum, n plus 1, the sum of both of them is the same thing as 5 out of 6 of their product. So 5 out of 6 times n plus 1. Okay, so this is a mathematical statement that defines the first sentence, and we can try to solve this now. So on this side is going to be 2n plus 1, right, is equal to 5 over 6. Well, multiplying, if I expand this, I would have n squared plus n. Okay, because n times n is n squared and n times 1 is n. Good. So we can, maybe you say cross multiply or multiply both sides by 6, whatever works, right? We shall have 6 brackets 2n plus 1 is equal to 5 by n squared plus n. Okay, expanding, we'll have 12n. I want to create space here, so 12n. 12n plus 6 is equal to 5n squared plus n, right? Collecting like terms, 5n squared plus 5n, my bad, sorry, 5n squared. So moving everything to one side so that we can have a standard quadratic equation, we'll have so equal to 0. I'm moving everything over here. I would have 5n squared plus 5n minus 12n minus 6 is equal to 0, right? So we'd have 5n squared minus 7n minus 6 is equal to 0. Good. So we need to solve this now, right? We write it in such a manner that it can be grouped, factored by grouping. That means we need to, split up the term in the middle, 7n. So we write b and ac, that's the hack we use. Add to give you b, multiply to give you ac. What is b? B is minus 7. What is 8 times c? That's minus 30. So we need to find two numbers that will add to give us b and multiply to give us minus 30. Those two numbers have to be negative 10 and 3. Yes, negative 10 and 3. Sorry, I'm managing space. That means that this expression here would be rewritten as 5n squared
minus 10n plus 3n minus 6 is equal to 0. Let me just write it somewhere else. Sorry, let me write it here. Let me write it here. 5n squared minus 10n plus 3n minus 6 is equal to 0. Okay. So we have written it in such a manner now that we are sure we can group with ease. I'll split this down the middle. So we can factor out 5n from the first group, right? That will be 5n bracket n minus 2, and we can factor out positive 3 here. That would also be n minus 2 is equal to 0. All right. So we can now we can factor out n minus 2 because n minus 2 is common to both groups, right? So we have n minus 2 out. From the first bit here, I'll have 5n. From the second part, factoring out n minus 2, I'll be left with plus 3 is equal to 0. So it follows that either n minus 2 is equal to 0 or 5n plus 3 is equal to 0. So the solutions for n is n could either be 2 or n could be equal to negative 3 over 5. Okay, but like when you solve this to 0. But when you look at it carefully, you're told that there are two consecutive whole numbers, right? So the value that it could be, n can only be 2. So that's the only rational solution, right? I mean, negative 3 over 5 is not a whole number, right? So this is going to be 2. The two numbers would be 2, n is 2, and then n plus 1 would have to be 3. So the consecutive numbers are 2 and 3. That's option B. So looking at this now, right, and then looking at how long it took me to get this solved. I don't know. I guess for some questions, trial and error probably would have gotten you the answer faster, right? Since it's a multiple choice question. But then again, it's good to know the solution just in case it pops up in essay. All right, but that's for question 92 though. So you can try it again a couple of times to be sure you're good. Okay, so 93 says, what is the smaller value for x for which x squared minus 3x plus 2 is equal to 0? What's the smaller value for x for which x squared minus 3x plus 2 is equal to 0? So we have x squared minus 3x plus 2 is equal to 0, right? I would solve this by factorization. So BAC, I'll write my back here, because the whole goal is to split this guy up into two values. All right, split this guy up into two values, such that the product of the two values in the middle, right, is same as the product of the two values at the end. So when we are done, splitting up minus 3x, the product of those values will be the same thing as the product of the two values at the end. Once we have that, then we can factor by grouping. Okay, but we have a nice trick, right? Just write out B and then AC. My value for B is negative 3, and then my value for A times C is 1 times 2, which is 2. All right, 1 times 2, which is 2. So this is going to become, look for two numbers that will add up to give negative 3, but multiply to give 2. Those two numbers would have to be, negative 2 and negative 1, right? Good. So that means that I can rewrite this now, all right, using these two lovely numbers I have here, as x squared minus 2x minus x plus 2 is equal to 0, right? So x squared minus 2x minus x plus 2 is equal to 0. I use the two values that we have here to replace the value for b. I can factor out x from the first set here, right? From the first group, I can drag out x. If I drag out x, I'll have x bracket. So x in x squared is x in minus 2 is minus 2. And then from the second group here, I can factor out negative 1. So negative 1 bracket x minus 2 is equal to 0. Okay, so I'll basically end up with with this, but I have x minus 2 common to both groups, right? So I can now factor x minus 2. So this is the actual grouping, right? Factor out x minus 2. From the first group here, I will have just x left. From the second group, I'll have minus 1 is equal to 0. Okay, we've successfully written this as a product of two factors, right? As a product of two factors, where we have
x minus 2 times x minus 1 being 0. And if two factors will multiply to give you 0, then one of them must be 0. So that means it's either x minus 2 is equal to 0 or x minus 1 is equal to 0. If this is the case, that means that x would equal 2. If the other is the case, that means x would equal 1, right? So our answers are 2 and 1. The question though is, what is the smaller value of x? So the smaller value is x is equal to 1. That's option C. Okay, so that's for 93. Let's take on 94. Okay, 94 says, which of the following is a factor of that? Okay, so which of the following is a factor of 2 minus x squared? All right. Now, we do not have the luxury of multiplying everything by minus 1 or moving things over because there's no equal to sign, right? So if you multiply by minus 1, when you don't have, the balance of two sides of an equation, then that means that you have actually distorted the current equation. So I'll just rewrite this in standard form, but, with a negative leading coefficient. So I'll have negative x squared minus x plus 2, right? That's what I have, okay? And then we'll do our regular factorization by grouping, whereby we need to rewrite this, the middle term, and the middle term must be written such that the product of the two terms in the middle that would replace the middle term would be same as the product of the two terms at the end. Anyway, we have this BAC to help us with that, right? So B is -1, all right? That's the coefficient here. And then A times C is -2, all right? What two numbers can we drop in, that will help us with this? We can drop in that would add up to give B and multiply to give us AC. That's the reason for the back. So when you write the back and you're not writing them down, you need to think of two numbers that would multiply to give AC but add to give B. Okay, so looking at it, those two numbers has to be -2 and +1. Yes, -2 and +1, and such that now we know that we can use those two values to replace the middle value. So it's going to be minus x squared minus 2x plus x plus 2 is equal to 0. So we use these two values to replace the middle value there. And now we can factor. So split them up in groups, two groups. From the first group here, I can factor out -x. All right, -x. Whenever what is leading has a negative sign, I'm sure to drag that negative sign out also. So -x, I'll be left with x plus 2 in here. And then from this, I can factor out +1 rather. And I also have x plus 2 is equal to 0. So I have x plus 2, that means I can factor out x plus 2. Factor out x plus 2, I will have x plus 2 out. From the first group, I have -x, and from the second group, I just have, when I factor out x plus 2, I'll just have +1. So these are my factors, x plus 2, and I can rewrite this as, just so that we have the leading term here, or the leading space occupied by a positive number, 1 minus x is equal to 0. So if we see either x plus 2 or 1 minus x, we'll be right. That's option A, 1 minus x. Okay, so that's for question 94. Let's take 95. Which of the following is a point on the curve? All right, so which of the following is a point on the curve? So any point on the curve would have to obey the rule, right? The rule of the equation. So I would just drop each of the rules in one by one and test. So the first one is we have 2, 0. So this means that x is 2 when y is equal to 0, right? So we can drop it in and test. If the left hand side and the right hand side are the same, that's fine. So let's test this. We're going to have, that means we're saying that we have y squared is equal to, sorry, not y squared, just y. Sorry. So y is equal to x squared minus 4x plus 7. So if I'm doing 0, 2, so I'll drop 0 for y. 0 is equal to 2 squared minus 4 times 2 plus 7. So 0 is equal to 4 minus 8 plus 7. 4 minus 8 is minus 4 plus 7, that's 3. We are saying 0 is equal to 3, not true. Not true, so that's wrong, right? Let's test the next one, 1 comma 4. Y squared is equal to x squared minus 4x plus 7, and we are saying that when x is equal to 1, y is equal to 4, right? That's the meaning of this statement. X is 1, y is 4. I don't know why I keep writing y squared. The question says y, not y squared. Okay, plugging in, we have y as 4. We're saying 4 is equal to x 1 squared minus 4 times 1 plus 7. So 4 is equal to 1 minus 4 plus 7. 4 is equal to minus 3 plus 7. 4 is equal to 4. True. All right? True. So that means that our correct option is option B. All right? And you can test the rest, that wouldn't work. All right? But the point that satisfies it is, of all of them, is 1, 4. Okay. 96 says, which of the following is not a factor of 2p squared minus 2? All right, so 2p squared minus 2. So let's stretch out 2p squared minus 2 and factor it best we can. 2p squared minus 2. I can factor out, so I'll have 2, then I'll have p squared minus 2 minus 1. But then this is a difference of 2 squares, right? And difference of 2 squares, they come in the form a squared minus b squared. And whenever we spot them, we are supposed to always remember that they can be written as a plus b multiplying a minus b. So this is a difference of 2 squares, actually, because this is p squared minus 1. 1 is also a square. That means I can write this as 2 bracket p plus 1 bracket p minus 1. So that means that all of these are factors. 2 is a factor. P plus 1 is a factor. Minus 1 is a factor of everything, right? Minus 1 and minus 1, they are factors, because you can always factor out minus 1 from anything, right? So they are factors. What is not a factor is 2p plus 1. That's option B. All right? So 1 and minus 1, you can call them universal factors, right? Okay, so that's for 96. Let's take 97. Which of these is not a quadratic expression? Right, so quadratic expression by nature, right, they have x squared. So that's it. Their highest power is x squared. So degree of 2, all right, you can see they have a degree of 2. That means the highest power is 2, all right? So this isn't. Because when you expand this, you just have 5x minus 5. So this is linear, right? It's not quadratic. And this one is, because when you expand this, you have x squared minus 5x. So definitely it is. So the option that is not a quadratic expression, that doesn't have x squared, is C. All right, or the highest power of x is not, that is C. All right, so we've come to the end of all the at least the part 1 of quadratic expressions, right? Well done, and good luck on your WAEC prep.